Good morning, everyone. It's my pleasure to welcome you on the second annual conference here in the center. And I would like, at the beginning, to give the floor to our director, Colonel Orlin Nicolo.
Thank you. Thank you, Robert. Actually, it's a great pleasure and honor for me to welcome you. For first time, this conference will be in our premises, and it's another challenge, and it's a great pleasure for us to see how it will pass. And together with Nina. Nina, are you here? Yes, you're here?
Yes, I'm here.
It's for us, it's a great pleasure to welcome you to the second international conference on environmental protection and disaster risk, and in the same time, 10th annual conference on crisis management and disaster response Center of Excellence. This annual event provides a wide platform for interaction and exchange among the CMDR community of interest, subject matter experts from NATO allies and partners, the academia, and the private and non-governmental sectors. This year's event will discuss crisis management and disaster response process in a global environment, environmental risk, and implication on all aspects of life, and high-performance computing. The unprecedented pace of environmental degradation, which threatens the existence of ecosystems and leading entire species to extinction, is deeply intertwined with human activities. Human activities also suffer from climate change as it increases the frequency and intensity of catastrophic events of different types. The ability to simulate and predict weather phenomena and effects is critical to the improvement of operations in the crisis management and disaster response domain. By changing the environment across critical components, climate change and weather are also affecting negatively military activities and hence necessitate during decision-making and planning processes. In this ever dynamic and harsh environment, the implications of climate change are unpredictable to a large degree, and while great progress has been made in the last decade in high-performance computing, much work needs to be done yet to enhance the ability to effectively predict effects. Placing the focus on this thematic, the CMDR COE seeks to inform adequate preparedness and contribute to timely adoption in line with the objectives of contributing to NATO's continuous transformation in the CMDR domain. This year's conference is devoted to the following topics into 5 panels. I'm sure that you are familiar with this one. Disaster management, natural hazards, risk reduction and building resilience, climate change challenges and security implication, air pollution and health, water resources and management, and the 5th one, informatics, remote sensing, geographic information system, high-performance computing, including all what I mentioned, and modeling and simulation, and artificial intelligence. I'm convinced that thank you to our common efforts, the second international conference on the environmental protection and disaster risk and the 10th annual conference of crisis management and disaster response will become an excellent venue for developing civilian and military capabilities to better prepare for predict, prevent, and respond to crises and disasters in support of NATO and partners' crisis management system. I would like to wish at the end of the conference to be with clear picture about how to continue to develop our endeavor for better prepared governmental institutions in the upcoming climate change and space weather environment challenges. All these topics are included in our portfolio in CMDR COE, and they are cross-cutting topics with crisis management and disaster response. From that perspective, for us as an expert in CMDR domain, will be a great pleasure and honor to exchange any kind of thinking, any kind of thoughts with you, and to start new projects and collaborate together in future. Thank you very much, and I don't want to waste more time and to give the floor to Nina Also, Nina.
Thank you. Dear colleagues, I would welcome you also from my side. I apologize for not being in person, but life is like that. Sometimes I cannot do what I want. Anyway, I want to say to everybody, and thank you for being with us to our combined coupled conference between the ENVIRORISK, the second ENVIRORISK edition, and the 10th Crisis Management and Disaster Response Center of Excellence Annual Conference. To both the physical and online participants, thank you to be with us. I would like also to express my sincere gratitude to Colonel Nikolov and his team for organizing and hosting this event. Without them, ENVIRORISK part would never happen. I have to admit that. And I will use the floor to greet also our co-organizers for the National Scientific Program of Environmental Protection and Reduction of Risks of Adverse Events and Natural Disasters, approved by the Council of Ministers of Bulgaria and by the Ministry of Education and Science, and also the National Roadmap for Research Infrastructure of Bulgaria called National Geoinformation Center, and GITS, funded under the National Roadmap and Scientific Infrastructure for the period 2017-2023. Last but not least, I would like also to thank the Bulgarian Academy of Sciences for their continuous support. And I would also want to wish everybody a fruitful discussions and successful participation to this event. Thank you all.
Thank you very much, Nina. Robert, now you can start the conference. I think that we can start our talking, our discussions, and our panel. As I know, the first panel, our moderators are Darius, Dubron, and you. But before this one, I think that we should have some kind of administrative instructions, and maybe someone will come and join us to see if it's possible to share some kind of administrative. Please, Emil. I wish you success in that time. And Robert, the floor now is yours. Just a second.
Good morning, dear guests and colleagues. Ladies and gentlemen, I'm an administrative officer in CMDR COE, and I will present you some administrative remarks very briefly. Please, during the conference, I kindly ask you to put your mobile phones on silence mode. For emergency situation, the European number 112 is supplied. Designated area for smokers are outside the building. We hosted 2 coffee breaks each day. One is not hosted. On 9:40, there is a group photo outside the building in front of the flats. This evening at 5:30 in Astoria Hotel, there is an icebreaker. And on 8th of June, we hosted the official dinner. Please welcome. This is the most important administrative remarks. Now it's time to give the floor to Conference Director, Colonel Robert Yursky, please. Thank you for your attention.
Thank you very much one more time. As already introduced by Director, I'm the Director of this conference. And I just want to present you very briefly 3 slides. It's also kind of administrative remarks. So you can see on the first one, very general schedule. The detailed schedule you received in the last days of May, but you can see it very general. And I just want to remind you that it's after each sets of briefing, there will be a designated time for the question and answer session. Just want to give you a few reminders because we have a lot of presenters, at least 52 presenters. So we are the time is kind of pressed. So please keep the time limit designated for your presentation, which means 15 minutes. Also, I would like to ask you to respect the time frames dedicated to the lunch breaks and also coffee breaks. And also, please keep your presented information up to the NATO unclassified level. Please use the microphone for addressing the questions. So it will be the microphone available here, and those people who would like to give the questions will be given the microphone and will be able to present the question. Also, for the people who are present on the online, you can use, for posting the question, you can use the chat box. Also, I would like to ask you to activate the silent mode in your mobile phones. You can keep those phones with you, but please activate the silent mode. And in case there is an emergency and in case you need to do some phone calls, please go outside of the room and make it. And I would like also to mention that in case of any problems related to the conference, you can see those 3 people, also including me, and please refer to us. I don't know if Sasha, Alexandrov, and Siana are available here in this room, but if yes, please, Sasha and Siana, please stand up just to introduce who you are. Okay, as the last reminder, I just want to mention that here in the center, we have a yearly publication. We are publishing in our proceedings all the matters related to our area of expertise. So I just want to encourage you to contact with us, and please, if you would like to, please send us your articles, your abstracts, and then we will publish it. For this year, we are going to release this our publication in October. But today or tomorrow, all of you will have in your mailbox the contact details of the person who is responsible for the details and also for publication. So if you are interested, please contact us. It will be a pleasure for all of us to have your articles here in our publishing. So the next point is a family picture. So at 9:35, please be ready to the family picture. And then after the family picture, we will start again exactly and sharply at 10 o'clock. So for the time being, thank you very much. And for those guys represented in the online, it's a technical break. Thanks a lot. Yes, but here is the we already Test. Ladies and gentlemen, now I would ask my colleague Dariusz Dobroń to introduce the first panel of the conference, and then we will start at 10 o'clock sharply with the briefings. Dariusz, please, the floor is yours.
Okay, thank you, Robert. It's a great pleasure for me to be here and to moderate today's panel. And as far as I correctly counted, this is my fifth annual conference of the CMDR COE, which I'm proud of. And coming back to the business, we are going today to touch a very important topic, which from my point of view is divided into three elements. The first is the natural hazards. Of course, by this we understand the hazards which are really caused by nature. So nature in spare. But also I think for hazards which are caused by human activity or human error as well. Then when we are able to identify those hazards, we can go to another step, which is the risk reduction. The risk reduction or trying to put pressure or put our effort to reduce the risk of the specific threat, which we try to identify in the first element. And by this, we are possibly able to build our resilience, to build up our strength, individual and in respective society or community. And today we have several of splendid briefers which are going to touch those topics, and they will present us, I am 100% sure, very interesting briefings. Once again, we are going to accumulate questions, and then there will be two sessions, one just before the lunch, and another session of question and answers just before the wrap-up of the day. So we have a sharply 10 o'clock. So without further ado, we are going to the first our briefer. Robert, can you?
Yes, I would like to ask Dr. Zornica Doceva if you are ready to start your presentation with a short introduction of yourself.
Yes, good morning. I'm ready. I will share the presentation right now. Dear colleagues, guests, ladies and gentlemen, this is a pleasure for me to open the session today. I'm an assistant professor in Sofia University, and the last few years, I work on research of the geological hazards and debris faults in Bulgaria. In the next slides, I will represent you the data that we obtain for, wait a second. The data that we obtain for the geological and geomorphological conditions and hazards that were performed in torrential catchments in the northern slopes of Belasica Mountain. This is located in southwestern Bulgaria. Torrential catchments are areas that are often affected by natural hazards, like different types of fast-moving faults, landslides, erosion, and the main triggering factor in most of the cases is short but intense rainfall. These events have destructive power and destroy infrastructure, buildings, affect the population, and their frequency and impact increased in past few decades. Uh, this is a result of climate change, urbanization, poor hazard and risk mitigation measures in some countries. Bulgaria is not an isolated case, and unfortunately, the disaster that impacted southwestern Bulgaria in December last year proves this. That's why we select for analysis 11 catchments that were affected by this flood event. They are located on the northeastern slopes of Belasica Mountain in Petriș municipality. The prone area is highly urbanized and the population is concentrated in Petriș town and Belasica and Quaru villages. The climate conditions in the area have a strong Mediterranean influence, with water flow increasing from November to March. But the floods are rare, but with high impact when they happened. The area is covered by forests and impacted by anthropogenic activity. The relief in the area is mountainous, with steep slopes that reach up to 60 degrees in some places. Geologically, the area is composed mainly of Paleozoic metamorphic rocks and Neogene quaternary sediments. The main fault structure is the Bulgarian normal fault, which is well expressed in the mountain's northern slope. The Belasica horst uplifting and formation of Strumeshnica graben are related to fault displacements, and this is happening in Neogene quaternary time. The main focus of our research is to analyze the geological and geomorphological conditions in the catchments and to understand what is their impact on the drainage network and the processes in the catchments. Another aim is to characterize the hazard processes that take place during the 11th of December flood event. For the purposes of the study, we obtained data from different sources like Aster Digital Elevation Model, field and crowdsourcing data like photos, videos, drone images, geological and topographical maps on different scales, Google Earth images, and data about the monthly rainfall. We realized a few field surveys to collect data and document the damages and sediment deposits. We analyzed the remote sensing data and maps to detect changes and characterize the deposition zones. For a better understanding of the relief and drainage network, we perform a catchment scale morphometric analysis based on the digital elevation model and performed in a GIS environment. Slope maps and basic catchment properties like area, perimeter, and basin length are also extracted from the digital elevation model. The flow chart with the steps that we follow for morphometric analysis is represented in the diagram. We calculate 20 morphometric parameters grouped into 3 classes: linear, relief, and aerial. The parameters were evaluated with the help of published mathematical equations. And let's see what happening in this event. The flooding was triggered by intensive rainfall that led to extensive damage in the Buhotu district, Belasica and Kularovo villages. And in the municipality was declared an emergency state. The flows carry a large amount of blocks, boulders, trees, and block some of the bridges in the area, and some of the rivers change their course and deposit sediments over the road network. In this event, a lot of houses were flooded. Intensive rainfall triggered landslides, and we document newly formed and reactivated already registered ones. Landslides destroy streets in Belasica and Kularovo villages and the road to Belasica hut. When landslides formed in valley slopes, they act as a sediment source, and when this source entrain in the stream, this leads to increasing in the sediment concentrations and thus change the flow characteristics. The observed deposits indicate a transition between floods and debris floods in most of the catchments. In the places where the slopes were highly moistured, the fine-grained materials starts to flow rapidly downslope and act as mud flows. Intensive river erosion was observed in almost all the catchments, and the fence, the stream channels were filled with plastic material. The results of morphometric analysis could be summarized as follows. The streams are from first to fourth order according to the Horton stream ordering system. The represented in the table configuration of the streams are distributed in dendritic and parallel drainage patterns. The values for the number of streams, stream length, mean stream length, and stream length ratio shows decreasing with the increasing of stream order. The values of the bifurcation ratio indicate a fast increase in and decrease in the fluid water surface. The calculated sinuosity index shows that the streams are straight or have a low sinuosity, which reflects the geological control over the stream network. Values for rho coefficient that are under 0.50 indicate low hydrological storage during the flood. The results for aerial parameters indicate moderate drainage density, coarse drainage texture, massive impermeable and resistant rock basement with steep gradients and high surface runoff. In the catchments where the drainage density is high, the host rocks could be highly fractured. Parameters that are related to catchment shape indicate elongated form and strong structural control on the drainage development. Results of calculated relief parameters indicate young, high relief, faster runoff, low infiltration, and intensive erosion. Meltdown ratio is a slow parameter that shows a good performance in distinguishing different types of flows. The result shows that the main type of sediment transport is debris flow instead of bed load and debris flow. But there is an indication for debris flow in catchments C9 and C11. These results are well correlated with the field data for the sediment deposits, weakly packed, very poorly to poorly sorted material with a pebble to boulder size that spread on the fence. The obtained results are useful for understanding the geology, geomorphology, structural properties, and the hydrogeological nature of the catchments, and could be summarized as follows. The study area is tectonically active and in young geomorphic stage of evolution with a well-developed drainage network. Geological composition and structures have a major influence on drainage features and the processes in the catchments. In the most of the catchments, the presence of massive resistant and impermeable rocks attribute to low drainage density, coarse drainage texture, and low infiltration. The area is suitable for a large amount of surface runoff that could be quickly removed if significant rainfall is received. The hazards that impact the area in December 2021 were landslides, fast and disastrous falls with indications for debris floods and mud falls, and intensive river erosion. The landslides that were activated acted as a sediment source that changed the fall characteristics and thus forming a hazard process chain. The Melton ratio indicates the development of debris floods in most of the catchments, which correspond well with the documented sediment deposits and the catchment's properties. And last but not least, morphometric analysis is a useful tool for understanding the topography features that impact the basin's hydrological processes. The area is urbanized and exposed to high risk, which requires more detailed research that will answer the questions. What is the rainfall threshold that trigger the processes? What will be the magnitude and the frequency? How do the processes interact in the catchments? What are the spatial distribution and risk zones? Answers to these questions will help to develop a complete hazard and risk assessment for mitigation and monitoring measures to reduce damages and economic losses and to prevent the hazards turn into disasters. Thank you very much.
Thank you very much, Doctor. And now we will smoothly go to another briefer, who is the Mr. Stefan Georgiev. Sir, are you ready right now to present your brief?
Hello, yes, I'm ready to present my presentation. Can you hear me?
Yes.
Okay. Can I go?
Yes, please. Yes, go.
Okay, hold on, just to share my screen. Okay, hope everybody can hear me.
Yes, it's correct.
Is it okay?
Yes, it is.
Okay, like you presented, my name is Stefan Georgiev, and I'm currently a meteorologist in the Health Suppression Agency in Bulgaria, and I'm also a PhD student here in Sofia University, St. Clement Ohridsky. It's my first time here in your conference, so it's a great opportunity for me to give you a short presentation about my work. As you can see, my work is related to radar identification of heavy dangerous clouds across the territory of Bulgaria. As you all know, the geographical location and climate features determine Bulgaria as one of the countries with high frequency of hail damages. The climate changes lead to more common and extreme weather events all over the world. There are several studies indicating that the frequency and the severity of weather events, such as hailfalls, flash floods, like we heard before, tornadoes and lightnings, is increasing. There are different existing scenarios based on numerical models for climate changes in Bulgaria, which indicate an increase in the frequency and the severity of the hailstorms. One of these studies, which is done by Peter Grönmeyer, is presented on the slide here on the bottom right, and it's the one which affected me the most, and it's my motivation for this work. His results of this study shows that Bulgaria is one of the regions for which is expected a significant rise in the severe hailstorms. Severe hailstorms are the storms which produce hailstone sizes above 2 centimeters in diameter. So the data that I use for my study is obtained thanks to the Bulgarian Health Suppression Agency. As probably you know, Bulgarian Health Suppression Agency is the only agency with operating network of 7 Doppler radars equipped with interactive radar information system, IRIS, which is a software from Vaisala. The radar data is obtained by automatic volumetric scanning at 14 elevation angles. The elevation of each scan increased from 0.2 degrees to 85 degrees with an irregular step. The rotation of each antenna beam is throughout 360 degrees of azimuth, and one full volume scan takes approximately 4 minutes and coverage range of 300 kilometers. As you can see on the bottom of my slide, you can see the coverage, the full coverage of our radar network. And on the bottom right, you could see with blue and red dots are presented the radars and their locations. We have 3 radars at North Bulgaria and 4 radars in South Bulgaria. Based on this radar network, from April to September, in real-time radar data is available for monitoring different atmospheric processes which pass over the territory of Bulgaria. This real-time data for radar information and the archive is useful, and I use them for complete analysis of the hail dangerous clouds and of course for nowcasting severe header weather events. This is a quick chart which represents how our radar works. Of course, on the top you have antenna, beam, of course you have X-band transmitter, S-band transmitter, and signal control and processing unit. Just to make clear, X and S stands for different wavelength lengths. X stands for 10 centimeters and S-band stands for 3 centimeter wavelengths. In the summer, we use X-band centimeters. This is to have a good, clear information about the hail dangerous clouds. All this information is transferred to the monitor, which you could see here. And in each 4 minutes, you could have a good idea about the vertical section construction of the clouds and their development during their lifestyle. What is done here in Bulgaria, there are different radar criteria that could be used to identify hail clouds. Currently in Bulgaria, the one that is used right now is the highest of 45 dBz, this is maximum reflectivity level, should extend to 2 kilometers above 0 degrees isotherm. The aim of my study is to try and find different criteria that better identify hail clouds and hopefully to be implemented in hail suppression agency activities. For my study, we have selected 170 thunderstorm cells, which are all over Bulgaria, and the period that we analyzed is from 2010 to 2021. All of the cells have different characteristics. Some were with precipitation of rain, some were with weak hail, and others with severe hail, and all of these cells were analyzed. On the bottom of the slide, I presented you one case which I have the privilege to analyze. This is a case developed in North Bulgaria, in Montana. In the first picture, you could see the initial stage of the cloud development, and in the last image, you could see the severity of the hail thunderstorm, and the hailstones on the ground were with probably higher than 3.0 centimeters in diameter, so we are talking about severe weather events. What we have done during the whole lifetime of the clouds, which sometimes were 15 minutes, 30 minutes, 45 minutes, it depends, at every 4 minutes, we were able to conduct a vertical cross-section, like you could see here, and measure and analyze the area of 15 dBz, maximum reflectivity of 15 dBz, 35 dBz, 40 dBz, and 45 dBz. Of course, we measured also the height of the area of the maximum radar reflectivity. Not only that, but in this every 4 minutes, we were able to obtain data for vertical integrated liquid and vertical integrated liquid density. It's obtained for 5 different temperature layers at every 4 minutes. And during the whole life of the thunderstorms, these parameters were analyzed. Last but not least, as you all know, the forecasting of hailstorm formation and development is a major challenge in operational meteorology. And these weather events usually are associated with large economic losses. Based on our analysis of the radar parameters during the lifetime of the thunderstorms, we were able to find different classification functions that can be used to identify the hail or no hail stage of the cloud development for each radar scan, and hopefully these results are going to be implemented in the next operational season of the Hail Suppression Agency. This was my presentation. Thank you for your attention.
Sir, thank you very much for your comprehensive brief, and if possible, we will go to the presentation of Dr. Vasco Galabov. It's face-to-face presentation.
Yeah, we are inviting you here, please come to us.
Васко, здрасти, чуваш ли ме?
It's a wrong presentation.
Can we show the presentation?
Sure.
Васко,
So fast like the human.
Yeah.
Здравейте, колеги, Червенко, чуваме ли?
добре, беше проба на звука сам.
Okay.
Yeah, I think so that this will work.
Okay. Hello. What I am going to present you now is a study, or at least some of the results of a study of the climatology of the waves along the Bulgarian coast, and in some area of interest along the Bulgarian coast, with extreme value analysis. Why the study is important? As you can see on the first two pictures, the waves may cause significant, mainly infrastructure damage, but over the years, they also caused even some victims. Sorry. The study is based on numerical simulation of the waves. Why is that so? Because there were no measurements in the past, instrumental measurements, I mean, of the waves. From 2020, the National Institute of Meteorology and Hydrology of Bulgaria already installed 4 wave buoys that measure the waves, but at present, we have just 2 years of data, and a few years before that, from the Institute of Oceanology of the Bulgarian Academy of Sciences. Therefore, the only method to do such a study is numerical modeling. So what I'm presenting you now is numerical modeling for a long period. That was implemented using 2 different atmospheric forcings. For those that are not familiar, this means the data about the winds at 10 meters height. The first source that we use is the so-called atmospheric reanalysis for the period 1950-2020 from the so-called Era 5 reanalysis, which is the state-of-art reanalysis that became available just a few years ago. And the other reanalysis that we use is the so-called ERA-CLIM, the outcome of the ERA-CLIM project, which is 110 years old and especially designed for climate studies. The modeling was done using two computational domains, the entire Black Sea, with a resolution of about 10 kilometers, and a smaller domain, which covers the area around the Bulgarian coast with much higher spatial resolution. In our case, it is slightly less than 2 kilometers. The goal is to study the wave climate of the Bulgarian coast using especially the newly available wind source ERA-5, and to do extreme value analysis. Here I show you the so-called area of interest. The white line is the border of the computational domain with higher resolution. And as you can see, it covers mainly the Bulgarian coast, but also part of the Romanian and Turkish coast of the Black Sea. And the results that I will show you are for two locations, Ahtopul, which is the southern Bulgarian coast, and Shabua, which is one of the northernmost points at the Bulgarian coast. And so we consider these two locations as some sort of representative for the southern Bulgarian coast and the northernmost. And also I will present you some integral data about the entire computational area. So some of the results, I'm not going too much deeply into the results. In our study, we defined two possible thresholds for a storm. The first one is a storm with significant wave heights above 2.5 meters high. And this is some sort of this is the so-called, on WMO scale, this is 5, grade 5. This is a rather regular storm. A few of this happen every winter. And here you can see for these 2 points the number of the storms for each year. What is visible, that there are some slight trends that were shown not to be statistically significant. Therefore, we cannot speak with confidence for any increase during the last 70 years. And here for these 2 points, I show you the energy of the waves. This is a cumulative for the year. And for these regular storms, again, there is no sign of increase. And if we define another threshold, 4 meters, or the grade 6 on the WMO scale, and if we consider this to be a significant storm, which does not happen every year, as you can see, for the northern location, Shabua, first of all, here for both locations, the most significant years are 2012 and 1979. These are the 2 years with the highest energy for the Bulgarian coast. While for the location Ahtopul, you see some increase. If we do some linear trend, I must tell you that this increase in the energy of significant storms should be taken with, let's say, some doubt, because it is still does not pass the tests for statistical significance. But anyway, there are some signs of increase. For the other vocation, Shabwa, there is no statistical significant trend. And here is the annual maximum of the significant wave height for two vocations. Again, there are some trends which are not cannot be proven to be statistically significant. And here is the so-called storm power index. This is an index that is studied for various vocations around the world. In general, this index depends on the highest significant wave height during a storm squared and multiplied by the duration of the storm. And if we are about to take some integral characteristics for the entire computational domain in the Western Black Sea, here are some of the results. Total annual energy of the so-called regular storms. You see that there are no signs of increase for the period. And the energy of the significant storms, while there is some positive trend of increase, again, it cannot be proven with confidence to be statistically significant. What about the extreme value analysis? The extreme value analysis for the two vocations, and as well as for the other vocations within the computational domain. Here I'm showing you only the two specially selected vocations, was done using the so-called generalized extreme values distribution. Here I'm not going too much into details about the procedure because it was done by one of my colleagues. I'm mainly presenting you the results. Sorry.
Can we go back to the presentation?
So here are the so-called return periods of the high waves for the two vocations of Topo and Shabwa. And on the first row, they are shown for the entire 110 years period. As you can see, they are much higher for Topo, and the second and the third row for both Topo and Shabwa, they are obtained for the first half of this period, which means the period from the beginning of the 20th century until half the 50s of the 20th century, and then for the second part of the period, which includes the second half of the 20th century and the first 10 years of the 21st century. What is visible that the return periods for the first half of the 20th century are significantly lower than the return periods obtained if we use only the second half of the 20th century. Does it mean that we have that this is an evidence of an increase of the intensity of events due to climate change? Well, it's a little bit preliminary, but it should be taken seriously into account. Another thing that we should mention as a conclusion of this study, for the location Shabwa, there is a very good fit of the data to the statistical distribution. In our case, this is generalized extreme values analysis using Gumbel distribution. But for the other southern location Ahtopo, the fit of the data to the distribution is much poorer. And therefore, these high values, for instance, 9 meters significant wave height for 300 years period, should be taken with, let's say, a little bit skeptical. The conclusions of the study about the wave climate, no statistically significant trends, but some weak trends are visible. And the other outcome of the study, much better fits for the generalized extreme values distribution of the data in the northern part of the Black Sea than in the south, which needs explanation. I have a few speculations about that, but this has to be studied in the future. And the most interesting thing, the return periods of the extreme events using the first half of the 20th century are smaller than those if we use the second half of the 20th century, which may be indicative of some increase of the extreme events. Thank you.
Thank you very much, sir, for your presentation. I just want to ask if we have, sir, I just want to ask if we have here in the auditorium, Dr. Radan Ivanov. Sir, I don't know if you are ready to present now or something. Okay. Thanks, Radan.
Just give a second to get comfortable with this. How does it work?
We will show the presentation. This is the pressing the slides. And I will prepare the presentation.
And the pointer, this one?
Probably, yes, the pointer. Yes.
Okay, thanks. Okay, so it seems it's time to start. This one is the first of two companion research presentations. The second one I'm going to show you a few minutes later. So the first one is about the evaluation of the fundamental frequency and damping of a cast in situ reinforced concrete building by ambient noise analysis. Here is the team. Special thanks to Dr. Emil Inaku, who did the data processing, and without the data processing, the research would not have been possible. And we are all from the National Institute of Geophysics, Geodesy, and Geography to the Bulgarian Academy of Sciences. Also, a brief mention of the research projects which made the research financially possible. They are shown at the bottom of the slide. A few words of introduction. The fundamental frequency and the damping of a structure are the key parameters participating in dynamic response analysis. And dynamic response analysis is what the analysis of and design of structures against earthquake is based on. So it's really important from a practical point of view. They can be determined by carrying out different tests, for example, free vibration tests or force vibration tests. And I'm going to show in the next slides why the method we have chosen is better than these two. Measuring microseismic noise and using various methods for its processing is the simplest and most reliable method for determination of the dynamic characteristics, fundamental frequency, and damping of the ground. There are many mechanisms by which damping occurs, for example, internal friction in connections or substructures, opening and closure of microcracks, friction between structural and non-structural elements, material damping, structure-fluid interaction, etc. Well, here on the left, you have equipment for forced vibration tests. You can appreciate how big and heavy it is, given that this is not strong vibration equipment. This is called small to medium vibration equipment by its manufacturer. So how it works? Well, it initiates vibration by off-center mass, by rotating some off-center mass. The structure then follows suit, starts to vibrate. We record all of this, and we can catch the resonant frequencies. Then on the right-hand side, you can see the setup for a free vibration test. You hit the structure by a hammer, or you pull it by a rope and then cut the rope, and then you record the free vibration response, which is shown at the bottom. Well, it looks pretty simple and beautiful, but you can appreciate that if you have to test a real structure, the hammer with which we have to hit the structure must be very big. So it's also an expensive way to test structures. Now, this is the building which we made our measurements in. This is our office, obviously the most convenient choice for a first attempt at this method. It is a 5-story reinforced concrete structure, cast in situ. In Bulgaria, cast in situ reinforced concrete structures are commonplace, so the results would ideally be representative for other structures as well. It was built in the 1980s. On this slide, we show on the top right is the location of the building within the city of Sofia. On the top left is blow up of this location. The building is surrounded by 2 other buildings, but there are joints between them. So we expected, and indeed the measurements proved that there is not structural interaction by the individual buildings, at least at this small scale vibration amplitudes that we measured during the tests. And on the bottom left is a simplified 3D model of the structure with the shear walls omitted. I will show in the next one where the shear walls are. So this is a typical floor plan. You see that the building is quite regular. which means that we don't expect significant torsional response. The lateral resistance is provided by shear walls. In the longitudinal directions, the shear walls are these two internal walls where the doors to the rooms are. And in the transverse directions, there are two shear walls at the two end walls. And there are also shear walls at the transverse walls between the rooms, but we're not sure where exactly they are because we don't have structural drawings. These are just architectural drawings. And for sure, where the elevator shaft is, there is a reinforced concrete core. This is the measuring equipment, and now you can appreciate the huge difference between the size of this, the white unit. This is actually the measuring equipment. You can put 4 of these in a shoebox. Actually, the battery, which is on the right, is heavier than the equipment itself. This particular one is made by Kinemetrics Etna 2. It can measure at sampling frequencies between 100 and 1000 hertz. We chose 100 because it's most economical, and also other researchers' guidelines indicated that for such type of studies, the most appropriate one. The equipment can be plugged directly into AC current, but for convenience, it's better to be equipped with a battery and a charger. Now, this is the algorithm for determination of the damping ratio by the random decrement method. First, you measure data from microtremors, then you apply a bandpass filter around the natural frequency which you expect to have. And the natural frequency you have to determine in advance by another method, which is called floor ratio. Then you apply the random decrement method, and by step by step, you try to isolate a free vibration, and then you fit free vibration response of a single degree of freedom structure to this response, and you fit by least square method, and the damping ratio of the best fit is the damping ratio of the structure. Now, this is how it looks for 1 point. On the left-hand side, the peak is where the natural frequency of the structure is. And then by step-by-step, so to speak, purification of the response of the structure, you fit by the red curve is the fitted response, and you obtain the damping in terms of damping ratio. Here are the results. I'm sorry for the small scripts, but generally we get damping ratio between 1 and 8%, which are within the possible range for this type of structure, but most of them are around 2-3%, which is again okay for such type of structure. And when we do statistical analysis, one good index for estimating whether the obtained damping ratios are good or bad is the fit between the natural frequency obtained by the floor spectrum ratio method and the natural frequency obtained by the random decrement method. In this case, you see that the fit is almost one-to-one. The equation on the top left is y equals 0.89x. Ideally, it should have been y equals x, but in practice, it's very difficult to achieve. Then simple statistical analysis indicated that with increasing frequency, which is on the horizontal axis, the damping ratio decreases, both for the x direction, which is the longitudinal, and y direction, which is the transverse. These are the principal directions of the building. And this is a volumetric plot of the distribution of the obtained damping ratios within the volume of the building. And doing this plot, with this plot, it's possible to see that in the x direction, the damping ratio tends to be larger than in the y direction. In conclusion, we made measurements at 10 vertical profiles, and the dominant frequency at the lower stories, -1 and 0, was usually 1 to 1.5 Hertz, which is interpreted as being the fundamental frequency of the underlying ground. So it has nothing to do with the building. The vibrations of the building at these levels are so weak that they are overwhelmed by the vibration of the ground. At the higher stories, the vibrations of the building begin to emerge, and two groups of dominant frequencies are observed around 2.2 and 2.9 Hertz, respectively, with an average damping ratio of about 2.5% and 2% respectively in the longitudinal, and around 2.5 Hertz and 3 Hertz with average damping ratio about 3 and 2.5 respectively in the transverse direction. Although the damping ratios are in the range used for design of RC buildings, which is normally 5%, the energy dissipation is not caused by nonlinear material behavior because the amplitude of vibrations is very low. The nonlinear statistical analysis indicated that a decreasing trend with increasing frequency for the damping ratio and consistently lower damping in the longitudinal direction compared to the transverse one. The same method as the one used in the present research has been applied for determination of the damping ratios of 82 cast in situ buildings in Xi'an, China, and trends similar to the ones of our study have been observed. So that's all from me now. There is another one in half an hour. Thank you very much.
Thanks a lot, sir, for the comprehensive brief. And after those 4 sessions, I suggest to have a coffee break, and we will start again with the presentation at 11:10. Thank you very much. Okay, it's the end of the break, and now I would like to ask Mr. Nicola Todorov to present his research. Hello, sir, are you with us?
Hello, yes. How do you hear me? Do you hear me?
Yes.
Okay. Give me a second to share the presentation. Just a second, I want to start the presentation and then to share the screen. Do you see it? Do you see the presentation?
Yes.
Okay. So first I want to thank the organizing committee for this conference and the opportunity to participate in this forum. My name is Nicola Todorov. I'm a scientist from Burgas University, Professor Dr. Asen Zlatarov. And I will present radiation background analysis on the land alongside Violet, Karagach River and Burgas Bay, which is a terrestrial survey. My colleagues are Sabina Netkova and Plamena Tanasova. The radiation background analysis is very important for the assessment of the radiological risk for every living creature. A source of external ionizing radiation. It's one of the components of an environment and is present everywhere and at the same time is of great importance because its level has a significant influence over the quality and length of life of living creatures. The present data on gamma radiation background is gathered as a part of multi-component analysis of environmental indicators of air, soil, fresh and salt water for the period of 10 months, June 21st to March 22nd, within a project funded by the Bulgarian-Turkey cross-border program named Cross-Border Regions Collaborate for Good Growth. The project aims to establish joint centers for applied research in the field of good growth, bringing together common research infrastructure existing in the universities in the cross-border region and to upgrade regional capacity to address key areas of environmental protection of river and marine ecosystems. One of the project's main ideas is the implementation of monitoring of aquatic ecosystem parameters, within which is organized collection of data on specific environmental parameters and the gamma radiation background. And the present research is part of this analysis. The data is gathered by Plamena Tanasova, Sabina Netkova, and myself, all researchers from Burgas University of Professor Dr. Asen Zlatarov. The presence of natural and man-made radionuclides in the atmosphere serves as an indicator for determination of the atmospheric radioactivity, which is determined by the indicator gamma background, or or the indicator that describes the impact of environment of living organisms, namely power of the equivalent dose of gamma radiation from the air. The natural gamma background is physical characteristic specific of the environment to every area. Above the Earth's surface, gamma background is created mainly by radionuclides, which are contained in the upper soil layer with a thickness of about 30 centimeters. For this reason, natural radionuclides of terrestrial origin from the three natural radioactive series play a significant role in the formation of terrestrial gamma background. Thorium and uranium series naturally present in soil, clay, and some kind of rocks, which include 47 various radionuclides. And widespread in the Earth crust, K40 and cosmic radiation. Give me just a second to close my window. Sorry. Thanks. According to the Bulgarian legislation, ordinance on the basic norms for radiation protection adopted by the Council of Ministers on the territory of Republic of Bulgaria, the natural radiation gamma background is in the range 0.06 to 0.40 microsieverts per hour. These values are considered as safe or normal. In the Republic of Bulgaria, there is continuous monitoring of gamma background by 5 departments. On the territory of Burgas district, which includes the areas of the surveyed ecosystems, systematic observation of radiological state of environment are carried out as an approved network of radiological monitoring, including points monitoring indicators periodically and mostly by the regional laboratory of Burgas, as well as regional health inspectorate. The program of regional laboratory Burgas for radiological monitoring of the environment in the territorial scope of the regional inspectorate of environmental and water of Burgas. This is implemented according order of the Ministry of Environment and Waters. National Automated System for Continuous Monitoring of Radiation Gamma Background consists of 26 local monitoring stations measuring the dose rate. The stations are located throughout the country, operate continuously, and send data to the central station of European Environmental Agency. The automated system is part of the European Radiological Data Exchange System and sends daily information on the radiation status in the country. On this slide, you can see a map of Bulgaria from the website of Joint Research Center, obtained on the 1st of June this year. There are several departments which are related to the measurement of the radiation gamma background at Burgas district. They are gathering data on average monthly values for the ambient equivalent dose rate from the local monitoring stations of Cape Emine and Ahtopo, which are circled with purple. They are part of National Automated System for Continuous Monitoring of Radiation Background within the Executive Environmental Agency of the Ministry of Environment and Waters. This picture is a screenshot again at 1st of June this year. Gamma radiation background monitoring of uncultivated soils in Burgas district and determination of natural gamma background above water is done once a year in 2 sample points. For surface waters, Lake Vaya and Atanasovsku Lake, and in 4 sample points for the sea: Black Sea, Vromus Bay, Black Sea near Nesebar, and Black Sea near Sinimorets, and Black Sea near Chernomorets, in the southeastern part of Bulgaria. The picture is taken by the website of Executive Environmental Agency and is for values on common bed activity of shallow water. But it's not placed here to illustrate that measurements are done regularly, but still rarely, once a year. And one of the main ideas of the project is to fulfill the data that is taken very rarely throughout the year. The data presented in this article is gathered as a terrestrial survey on gamma radiation dose rates over land and sand alongside 3 types of large water objects in the southeast part of Bulgarian Black Sea coast. Lake Vaya, a river, and Burgas Bay, port of Burgas, and the beach shore. The survey is done with 3 different dosimeters, which measure gamma radiation and ambient dose equivalent rate using Geiger-Müller counters. In radiation, dose readouts, the dose readout is in microsieverts for an hour, placed 10 centimeters above the ground at especially selected monitoring points. The data is gathered just a second. The data is gathered The data is gathered for a period of 10 months, as I already said, June 21st to March 22nd. You can see the devices. The first one is Voltcraft. The second one is SOEX, and the third one is Terra MKS-05. The algorithm used for determination of terrestrial gamma background has been developed for the purpose of the project in a methodology for gamma radiation determination, which includes following steps. The area in which it will be measured is determined as a rough circle with radius of 1 meter and the center, the sampling point. Those meters are switched on and prepared for operation within the surveyed area around the sampling point. The radiological examination includes 3 points to stop to measure the background. The 3 locations are about compass directions of 0, 120, and 240 degrees, and are placed in an area that is considered not to be artificially contaminated. The area thus formed is traversed at a speed of about 0 meters per second, approximately half a step per second. The movement of the hand of the operator with the dosimeter in it is in the form of Latin letter Z. The dosimeter is held about 10 centimeters above the ground and for registration of gamma background from the area. The data obtained is recorded in a protocol. Burgas Bay, port of Burgas, is the largest bay on the Bulgarian Black Sea coast and one of the largest in the Black Sea. Alongside its coastal line had been selected five monitoring points and sampling points on which are measured different parameters of the environment, including gamma radiation background. Monitoring points locations were chosen in accordance with the anthropogenic pressure and accessibility for the Burgas Bay and Port of Burgas ecosystem. There are 5 sampling points which you can see on the map. Gathered data is divided on sampling points, months, and dosimetry devices, and presented with chart on this slide. It is seen that the detected gamma radiation does not exceed the normal boundaries up to 0.14 microsieverts for an hour, except in March 22nd, in sample points 4 and 5, the highest values of the gamma background above the cement breakwater in the shallow water of the central part of Burgas Beach, and over the sand at the area of Salines of Burgas. They are detected by Voltcraft gamma check Geiger counter. The sampling point 4 on the 8th of March is detected a value of 0.42 microsieverts for an hour. And on the same date, at the sample point 5, a value of 0.48 microsieverts for an hour, which is just a little bit over the normal value. Lake Vaia, or Burgas Lake, is the largest natural lake in Burgas, a shallow brackish coastal lake, an open estuary slightly connected to the sea. It is located west of Burgas and its entire eastern part borders the industrial and residential districts of the city. It is connected to the sea through a canal with a sluice, which provides vital fresh water from the sea, as well as nutrients and marine flora and fauna in the otherwise mostly freshwater lake. 3 rivers flow into the lake: Aituska, Sandere, and Chukarska, which are very important freshwaters. This makes Vaia Lake extremely interesting ecosystem which combines the salt and fresh water, as well as the industrial and domestic influence of the city, and thus creates unique environment. The sampling points are presented on the slide. They were chosen to be accessible by foot to reflect the anthropogenic impact on the ecosystem and not to match the sampling point of executive environmental agents. The data of the dosimeters is presented at this slide. It is seen that the following data gathered at the first surveyed ecosystem, Burgas Bay or Port of Burgas, the highest value of the gamma background above the land alongside the boundaries of Vaia Lake is detected by Voltcraft gamma check Geiger at sampling point 1 on the 21st of February this year, which detected gamma radiation background of value 0.48 microsieverts, which is a little bit over the normal value. The Karagach River is a river in the southeastern Bulgaria, flowing into the Karagach Bay on the Black Sea. Its length is a little bit more than 30 kilometers. The valley of the Karagach River is one of the typical drowned valleys of the southern Black Sea coast. Kitenska River is extremely rich in fish and rare plant and animal species. It flows through the karst area, which is the reason for the loss of water, in its riverbed. The river Karagach and its area is protected area under the Directive of Natural Habitats approved by decision of Council of Ministers with a total area of 64 hectares, protected area, and under directive on the conservation of natural habitats and wild flora and fauna. The sample points are 5 and are chosen to be accessible to present the anthropogenic influence over the river and not too much the sampling points for monitoring of environmental indicators done by some of responsible institutions. The data of the dosimeters alongside Karagachi River determined at the period of the 10 months is seen, it can be seen that here also the highest values of the gamma background above the land is detected by Voltcraft Gamma J Geiger counter at sampling point 2 on the 22nd of November and on the 8th of December with values of 0.48 microsieverts. Within the project, we had gathered a lot of data on the environmental indicators, which describe 3 types of large water objects in the southeast part of Bulgaria, Black Sea coast. A river, a bay, and a beach road. The data on the terrestrial survey on gamma radiation dose rates over the land and sand alongside the surveyed ecosystem had been regularly taken every month on the same sampling points and would form a broad experimental data for further studies on the effect of gamma radiation on people and living organisms alongside and as a part of common environmental status of the area. The data shows values of gamma radiation which are at the limits of the normal numbers. Up to 0.40 microsieverts per an hour, with few exceptions, which are quite near to the safe values. Thank you for your attention.
And we will go directly to the briefing of Dr. Luba Dimova.
Hello, good morning.
Good morning. Good afternoon, actually.
Almost, yes. First of all, I would like to apologize for my camera resolution. And let me share my screen. Do you see it now? Okay, so my name is Luba Dimova, and I work as a research assistant in the Department of Meteorology and Geophysics in the Faculty of Physics, Sofia University. The topic that I would like to present is historical earthquakes and tsunami waves in the Sea of Marmara, review and modeling. And this is a part of a project that I manage related to tsunami hazard assessment in the southeastern European region. My co-author is Associated Professor Renata Raikova. So the methodology that I use, it's quite simple. First of all, I take into account historical seismicity in the region of interest, large earthquakes that produce tsunamis. After that, we identify the tsunamigenic source. It could be an earthquake, landslide, volcanic eruption, or even meteorological disturbances, the so-called meteotsunamis. In this case, I am only focused to the earthquake that generated tsunamis. After that, we are searching for data that describes the focal mechanism of large earthquakes in the region. The geometry of the fault is constructed in accordance with the European database of seismogenic faults, and it is calculated via regressions proposed by several authors. The computational grids that I use, mainly they're built from bathymetry and topography data. The better the resolution, of course, the better the results. The initial conditions for the tsunami generations, they are calculated using the Okadas method proposed in 1985. And for the tsunami propagation and several other outputs like maximum elevation and synthetic mariograms, tsunami travel times, tsunami time travel maps, I use a model that is developed in University of Bologna, Italy, called UBO-ZUFT. So this is our region of interest. As you can see, it's very complex. We have the African plate submerging beneath the Eurasia and Asian microplate. Here, southern of Crete, we have a large subduction zone. To the north of Crete, we have a volcanic arc. On the eastern part, the Arab plate moves northwestern to the Anatolian, and the Anatolian plate moves westward to the Aegean plate. And here is the larger, the North Anatolian fault zone, which is a major dextral strike slip fault zone, or right lateral, which is placed on the boundary between the Anatolian microplate and the Eurasia. So the northern part of this northern Anatolian fault passes through Izmit Bay and Marmara Sea, where a lot of earthquakes happened in the history. So from the second map, we can see the GPS velocities relative to the Eurasia. We can see they're bigger here on the southwestern part. So this is a map showing the seismicity in the region for the period, for the last century and almost 22 years. With the small black circles, the seismicity is between, the magnitudes of the earthquakes is between 3.5 and 5.9. And the red circles show the seismicity for earthquakes with magnitudes larger than 6. The brown lines show the main seismic faults in the region, and they're taken for the database that I mentioned before. Two of the largest earthquakes happened last century are shown here in the table. Both of the earthquakes, they're estimated with magnitude 7.4. And you can see here in the table the total number of deaths and the collapsed buildings after the earthquake. This is a map that shows the tsunami events, the tsunamigenic events in the Sea of Marmara. We have around 34 events since we have a database for tsunamis worldwide. I chose 2 events that I will show you some results for the numerical modeling. The one is in the beginning of the last century. In 1912, the so-called Sarkoi-Murefte earthquake. We can see the maximum tsunami height was estimated as 2.7 meters, but the cause of tsunami is most likely earthquake and a consequence of underwater landslides. So I have modeled only the earthquake process. And the other one, probably some of you know this earthquake. In August 1999, near Izmit in the Kocaeli province. You can see those are the total number of deaths due to the tsunami. And this is the estimated maximum water height, about 2.5 meters. The number of run-ups, those numbers shows the estimated at some points, it's inundation at some points. So for the second earthquake, we have 26 locations that the waves inundated some area. Those run-ups, they're on land, not in the sea area. So this is our map with the seismic sources. I chose this one. They are taken from the database that I showed you before. In this database, we can see the main features of the focal mechanism, the triangle strike, dip, and rake. We can choose the geometry, length, and the width, but of course, it should be in accordance with other geological and tectonic features. We have the annual slip rate in millimeters, and in some cases, we have the maximum moment magnitude for those sources. RL means right lateral, which is strike slip direction. This is our computational grid, and here are some of the technical parameters that I use. The spatial resolution is 250 meters. The data is taken from GIPCO with 15 arc seconds that was distributed last year. It is open access, and it covers both bathymetry and topography data. The time step of each step of the grid is 1 second, and here are the nodes and in X and Y directions. So for the Kocaeli earthquake, I have chosen several focal mechanisms distributed by different authors. You can see with those red pins, the epicenters are located in very vast locations. And it looks like the focal mechanisms are quite the same, but actually it's not like this. So here, NAIC, and they have 3 times, they have reviewed this earthquake, so they have 3 different focal mechanisms. And for the other earthquake, unfortunately, it is quite far from now, so I only found 1 focal mechanism in a paper. So here are our initial conditions. I tried to summarize some of the parameterization here. For example, for the Sarkoi-Morefte earthquake, I have here 6 different parameterization with different length, width, and displacement over the fault. And with the focal mechanism, the first nodal plane, and here is the second one. And for the second earthquake, I have around 18 scenarios, but here are shown only some of them. To the right, you can see the minimum and maximum elevations that are computed using the Okada method. And actually, those parameters, they're our initial conditions for the tsunami propagation. So here on this slide are presented 4 different solutions for the initial conditions. On the above figures, you can see the 2 examples from different data centers. This is the International Seismological Center, their solution for the focal mechanism. And this one is from another one. You can see it's the location of the epicenter is quite different, but the estimated values, they range in almost the same range. Below is the other earthquake, the first nodal plane solution. It's quite beautiful, I can say, and it's in accordance with the geographical position of the fault. While the second one, you can see it's perpendicular, and from now on, I won't show you any results about this one. It's excluded. So those figures show the maximum tsunami heights or the maximum elevation computed for 3 of those scenarios. Here is Kocaeli and Izmit Bay. It is quite narrow, and we can see that the tsunami waves are concentrated in the bay, while on the second earthquake, we have propagation of the tsunamis almost to the central part of the Sea of Marmara. Here we can see that the elevations reach almost 1.3 meters, which is in accordance with the observed tsunami at this time, while for the first two cases, we have an underestimation of the values. These slides represent the tsunami travel time maps, which are very useful in tsunami early warning system. You can see each color represents 5 minutes of the simulation, and it's quite useful to see after what time after the earthquake the waves reach certain point. Again, in the first case, the tsunami waves are trapped in this so-called channel, while the second, with the second earthquake, we can see propagation through this is Dardanelli and Çanakkale, Dardanelli Strait. Yes, so those are places of so-called synthetic mariograms. They're placed close to points where the tsunami was observed from different researchers, or it was described in papers. So there are around 50 different points, and I selected to show you some results for the COE Murefte earthquake, which is placed somewhere here. I've taken one synthetic mariograms offshore COE, one near Tekedak and one near Çanakkale. And for the other earthquake, I chose 3 mariograms near this bay. So those are the results. We can see very short period oscillation in some of the synthetic mariograms. In 2 of them, we can see first the receding of the sea, because sometimes the tsunami waves are not always penetrating inside the land, but sometimes there is a retrieving of the sea, and after that the wave is coming. Here near Istanbul, it's very large period, but here the oscillations are quite insignificant. And these are same mariograms, but zoomed for the first 30 minutes. Here we can see the receding of the sea on both of the mariograms, which is confirmed by historical records and information in different papers. And to conclude, I would say that the methodology is very important in tsunami simulations. We must go through the open access catalogs for seismicity in the region. We must investigate the specific seismic source. Here are the authors that I cite here, that I chose to use their regressions, which are related to magnitude and the length and width of the fault. The model is used to simulate scenarios for the 2 earthquakes. And this model is based on Navier-Stokes equations in the approximation of a shallow water theory and coupled with bathymetry and topography data. A total number of 6 scenarios for the first earthquake are made, and 18 scenarios for the Kocaeli, here is a mistake, 1999 Kocaeli earthquake. A total number of 51 synthetic mariograms are constructed. And the most important thing is if you would like to view the inundation line on the coast, more precise bathymetry and topography data is needed. And this is our future work, to build nested grids in several locations that are of interest with more detailed data for the bathymetry. Here are some references, and I would like to thank for your attention. That's it for me.
Dr. Dimova, thanks a lot for your comprehensive and informative brief. And now I would like to ask Dr. Radan Ivanov for another presentation.
Full screen.
Can we do the presentation mode?
Thank you, Mr. Chairman. Dear colleagues, this is my second contribution for today. It is a companion paper, the first one I did in the morning session. The research team is the same, again with a major contribution by Dr. Emil Oinako for the data processing, and again the financial support by the two projects indicated at the bottom is the same. They are greatly appreciated. Without them, this research wouldn't have been possible. So this talk is about the evaluation of the fundamental frequency. And sorry, this is the same paper I did in the morning. Can you please load the other one? There is Nakamura in the name.
Nakamura index.
Yes, yeah. Yeah. Okay, so this is about evaluation of the Nakamura vulnerability index of a cast-in-situ reinforced concrete building from ambient noise records. The building is actually the same which I showed you in the previous presentation. The investigation of buildings of social or historical significance by non-destructive geophysical methods is considered largely beneficial as a preparation for renovation and strengthening works. Some of the widely used geophysical methods are those relying on the analysis and interpretation of ambient noise, and more specifically, methods based on the horizontal to vertical spectral ratios, initially introduced in Japan. By the way, such methods have been used for assessing the structural health of historical heritage of such scale as the Coliseum in Rome, the inclined Tower of Pisa, and other notable historical monuments as well. The Nakamura technique for buildings considers the investigated structure as an equivalent linear system in which the records of the horizontal channels are assumed to be the output signal, whereas the records of the vertical channel are the input ones. So, figuratively speaking, a black box problem is solved, and the characteristics of the vibrating object are extracted from the input and output signals. A few words about the general processing which is involved in the method. First, you have to take recording of the ambient noise. Depending on the expected natural frequency of the structure, it has varying length, but in general, it shouldn't be less than 10 minutes long and is usually 20 to 30 minutes long. So for our structure, 20 minutes was considered enough, so we took 20 minutes records. Another important step is to take truly ambient noise window segments, which are shown here on the slide with green. You see that they are relatively uniform. There are no notable pulses or other transient disturbances inside the green windows. This is done by a specialized algorithm, and if you don't consider this, if you take the white windows as well, where you can see there are huge spikes, the results are not good. The method still works, but the results are not good. So after you separate the good data, then you simply calculate the Fourier spectra of the horizontal components and the Fourier spectrum of the vertical component. You divide the horizontal to the vertical, and you compute the so-called amplification ratio, which is on the vertical axis. And where the amplification shows maximum, this is where the predominant frequency of the vibrating structure, of the investigated structure is. So in this case, on the right, you can see where the natural frequency of the building is. The building is the same. Well, in our institute, we stick to the principle that we have to kill two birds with one stone, and if possible more. So from the same building, we decided to do another type of research. So I'm not going to repeat all the details. The measurement equipment is the same. It takes about 1 day or sometimes 2 days to cover a building like the shown in the example. Depends on how many measurement units you have. In our case, we had 4 units, and we managed to do it in 2 days. And now a few words about what this so-called Nakamura vulnerability index actually is. If we consider that not all the ground motion goes into setting the building in motion, first we introduce the so-called effective ground motion, which is simply a percentage of the ground motion which appears at free surface. It's usually around 60%. Then from the ambient records, it is possible to compute the story drifts, which are shown on the scheme of the building on the right-hand side. And from the story drifts, the third equation from top to bottom, it's possible to compute the drift angle, which is a simple geometrical property. And if you introduce the vulnerability index K sub BI to be this property shown on the third line on the right-hand side, then you can appreciate that what the meaning of the Nakamura index is. It is actually how flexible the structure is at the particular location of measurement. And although flexibility doesn't immediately translate into vulnerability, if all other things are equal, then it does. So it is just a rough guidance of how the building is flexible at certain points. It is also possible to compute average vulnerability index. If you take the amplification factor, this is in the nominator, and with capital F in the denominator is the respective frequency, And if you take the total building height, then it's also possible to compute average vulnerability index, which is used for rapid studies. If you don't have time to cover the whole building story by story, then you can just put your equipment on the top and compute the average vulnerability index. Before going into the building, we also measured H over V spectral ratios for the ground around the building. And it appeared, as you can see from this graph, that the natural frequency of the ground is a little higher than 1 Hertz, because the peaks in the beginning are around 1 Hertz. And vulnerability index for the ground was computed as 1.12, which again, it is not to be considered as an absolute value. It is just a relative term, but values less than 2 or 3 are considered good, meaning that it's not likely the ground to be damaged by earthquake motion. So after computing the index for the ground, we went on and we computed the amplification factors for each profile. There are 10 points on each story. They are called profile 1 to profile 10. And now I'm going to explain briefly the meaning of each of these figures. On the horizontal axis, you have the frequency, and on the vertical axis is the ratio between the Fourier spectrum of a horizontal component and a vertical component. So where you see peaks, these mean natural frequencies of the building. Now, for most figures, you see that there are peaks around 2.5 Hertz and 3 Hertz. This is for points 5 through 6, and the last two. And sometimes the largest peak is at 2.5, and the second one is at 3, like for 6 and 8. However, sometimes, like for profile 7 on the bottom left, the largest peak is at 3. So it doesn't mean that the fundamental frequency changes. It simply means that for the particular measurement, the frequency which was excited at this exact time when the measurement was taken is 3 Hertz. It's not 2.5 Hertz. So both of them are equally important. Now, another thing that is especially visible for profile 2, this is the picture on the top right, each line represents the response at a particular story. And the line with the largest values is the line on the top story. It means that if you want to get any trends about the flexibility of the building, the first, like the best candidate is the top story. And the other stories, they also reveal a similar trend, but it is not so pronounced. So in practice, if you want to do this analysis, you better start at the top and go to the bottom if necessary. Now, all this data from the figures is put into a table. Now, on the bottom line of the table, we have also computed drift angle, which corresponds to the largest plausible earthquake that might occur in Sofia. We have assumed this to be with peak ground acceleration of 0.36 G. And the largest value is for profile 4, and it was computed as 1/700 of the story height. And usually collapse of buildings, depending on the structural material and the structural type, happens when this value is 1/200, 1/100. So very roughly, of course, we can say confidently that this building wouldn't collapse for an earthquake, for the maximum earthquake that would likely occur in Sofia. Well, it's not a guarantee, but probabilistic hazard analysis studies indicate that this is an earthquake that might occur once in 1,000 years, this type of frequency. And now this is an interesting picture which shows the distribution of the vulnerability index along the stories of the building. The most interesting one is on the top story. The shear walls, which provide the lateral resistance of the building, are along the left and the right in the transverse direction, in the smaller dimension. So usually you would expect the largest deformations to occur at the ends of such type of building. However, you see that the largest index, or in other words, the largest deformation occur in the middle. And in the green zone, this is where the elevator shaft is. The vulnerability index is smallest. So this is an indication that the largest contributor to the stiffness of the building is the elevator shaft. And immediately after the elevator shaft, there is some, you can call it vulnerability, but it's not necessarily vulnerability, it's just a flexible point, which you normally wouldn't expect because the slab of the building is 18 centimeters thick. And in structural engineering, when you have a slab like this, you would assume it to be infinitely rigid in its plane. So you don't expect such changes in the flexibility. However, when you do a study like this, you can catch such unexpected things, and then you can think about them in perspective and take precautionary measures or some kind of strengthening if necessary. And in conclusion, I can say that in the present investigation, we obtained vulnerability indexes KB and coefficient of vulnerability KG of the building and the surrounding area, respectively. The maximum value of the vulnerability index was 81 at the location where the largest H/V ratio also reached its maximum. The location is identified as possibly the most vulnerable one in the whole building. And the maximum inter-story drift angles were determined for a scenario of maximum plausible PGA, and we conclude that the building would likely not be damaged by it. Thank you for the attention again.
Thank you very much, Doctor. Thank you for the briefing. And if possible, I would like to welcome again Dr. Vasco Galabov. Can we start the presentation?
Hello again. My first presentation was about the sea waves. And now I would like to talk about another dangerous event that endangers the coasts, which in some cases may be even more dangerous, but it's important to mention that it always comes in combination with high waves. And this is the major cause for the coastal floodings, or namely storm surges. For those that do not know what is this is the increase of the sea level in shallow waters that can be very high for some oceanic coasts. Also, as far as I know, in the Baltic Sea, especially in places such as St. Petersburg, also in places like Venice can be very high and can flood the urban areas. In the Black Sea, this is a rare event. However, the Bulgarian coast is the most vulnerable to such events, and while for the other seas, this sea level increase can reach more than 2 meters, sometimes much more than 2 meters. In the Black Sea, it can reach, let's say, 1.5 meters are the highest known events. However, it was such events of just 1.5 meters were enough to flood towns like the town of Pomorie more than once. The most vulnerable areas are the big shallow bays, and on the Bulgarian coast, the most vulnerable is naturally the Burgas Bay, which is meanwhile the center of economic activity around the coast, with port infrastructure, industrial areas, towns. The variations of the sea level in Bulgaria are recorded for a long time, nearly 100 years. However, during some of the most significant storms, the data is missing. Therefore, the main tool which we tried in this study is numerical modeling again. The model that we use is a hydrodynamic model that belongs to the so-called quasi-two-dimensional models, which means that we take some integral current velocity over some average for some layer of the sea. The input atmospheric data in that case is the wind, the components of the wind and the mean sea level pressure. And again, as in the previous study, it comes from the ERA 5 atmospheric reanalysis. And there is some connection between the model for the storm surges and the wave model. Here is the Bulgarian coastal zone. And you can see there the Burgas Bay, the biggest bay, which is also shallow and vulnerable to such events. The other area which is potentially vulnerable is Varna Bay, which is also a center of economic activity and industry. So some of the outcomes of the modeling. First of all, we are setting different thresholds Here I'm showing you the number of events for which the sea level can increase by 40 centimeters or more. These events, 40 centimeters, they are not dangerous, but it's important to notice that over the last 70 years, we do have statistically significant increase in the number of events, which means that at least these small events increase. And here is the duration of these events above 40 centimeters. As you can see, the duration does not show a tendency to increase. Therefore, during the recent period, we have more events like this. However, they are shorter in duration. And if we set a higher threshold, 60 centimeters, this already can cause some disturbance, like, but not major flood. Here, there is no pronounced tendency for an increase. And if we set a threshold of 80 centimeters, above 80 centimeters, we can have some coastal floodings and dangers for the coasts. Again, it seems that there is no pronounced tendency for an increase in the number or duration of events. And here you can see the annual maximum storm surge in meters. The most important events are the events of 1977, 1979, which is not the highest, but the longest event in duration, which caused significant damages. That was February 1979, flooding of the town Pomorie. And after that, one of the two highest, at least as an outcome of our modeling, 1981. The event of January 1981 is well recorded by the citizen of the town of Pomorie and other towns. And 2012, which after 30 years gap again caused some coastal inundation and damages. So as you can see, the highest events around Bulgarian coast are, at least for what we know, about 1.5 meters. And speaking about the measurement data, unfortunately, I'm missing now some slides about the instrumental recordings, but the problem is that, let's say we have enough data from 1979. However, at the peak of the storm surge, because the tide gauges at that time were not designed to measure above 1.5 meters, they did not record at the highest values because they were inundated. In 1981, there is a partial data, and in 2012, the measurement data is missing. Due to some reason, the tide gauge system was not functioning. As you can see, this system is suitable over the years to record the sea level in the tendencies over the years for a sea level increase, but not exactly to study the storm surge events in the past. And here is some index that we introduced, which is some sort of analog to the storm power index when we speak about the waves. And again, extreme value analysis. what is interesting here to notice that again, for the southern Black Sea, the fit to the theoretical statistical distribution was poor, while for the northern part, it is better. And these are the return periods of extreme events. For Burgas Bay, as you can see, we estimated the 300 years, the event with 300 years return period to be about 2 meters, while for Varna Bay, 1.5 meters. But this value for Burgas Bay of 2 meters sounds, while it sounds quite alarming, it should be taken with some suspicion because, as I mentioned, the extreme value analysis shows that the fit is far from being, to the distribution is far from being perfect. And therefore, this part of the study shall continue in the future to clarify what is going on. Just an example here. As you can see, the fit for Varna is much better than the fit for Burgas. The highest events, and as I already mentioned, in 1979, 1981, and February 2012. Also, it's important to notice that there was a big gap with without such extreme events between 1981 and 2012, nearly 30 years. Finally, it's important to mention that in the future, due to the climate change, the Black Sea level is expected to increase. The same way as the level of the global ocean, which instead of reducing, will increase the vulnerability of the coast from such storm events, taking into account also the increase due to the climate change. Yeah, thank you.
Thank you very much, Doctor. And now there is a time to pose the questions to the presenters, and we can check if we have some online questions. If not,
let's start from the floor, maybe.
Yes, if there are some questions, please, we can take them right now. There is a time to do so. Nie wiem, to możesz zaczynać.
And that was in this some of the movies, and now became the silence. Okay. First of all, I would like to thank you very much to Mr. Radan Ivanov. Thank you very much, because after your briefing, especially the last one, I just realized that I did the best choice in my hotel. Firstly, I thought that I was punished by the room close to the elevator. Right now, I know that this is the safer place, especially on the 9th floor. So it was the good choice, at least for the staying here. Secondly, I spent here in Bulgaria almost 4 years, and when I was looking on some residential estates, I was wondering why they not collapsed already by themselves. But a short question to you: is your data and analysis can be used by the local community to make a kind of matrix or a map? Which of the buildings are the most vulnerable, or the areas can be vulnerable for potential trembling? I mean, earthquakes, yes. And then for the local authorities, this would be a good perspective where to put the effort to make some reconstructions if they are really needed, or where to put the main stress for rescue teams to be ready to go there, because those places probably are the more vulnerable for such events. Can you say something like that? Can I ask for the microphone to be in the? Yes, I think this one. Is it turned on?
Yes, it's what I supposed about what I supposed about in the second presentation for assessing where individual building is most vulnerable for resources. It is difficult to make an example two buildings of different types and say by the results of the method which building is more vulnerable. There are other approaches to it. And it is for some
Maybe can we invite you here without using this microphone, then we will stop this background noise. By the way. Yeah, please.
Okay, nice to be on the sofa again. For Sofia in particular and Bulgaria in general, it is basically known which structural types are most vulnerable against earthquake. It is also known what their vulnerabilities are. And you would do a study like the one I showed in the second presentation to enhance the exact approach for strengthening a particular building. But it cannot show you directly that a masonry building is worse in some sense than a reinforced concrete building. It is clear by itself by other studies and by theoretical analysis as well. We know very well that a masonry structure is much weaker than a reinforced concrete structure. And also we know in general that well-built steel structure is a little bit better than a well-built reinforced concrete structure. So this method is to pinpoint the weak points of a structure. Once you decide, I want to strengthen this one, you do this study and you pinpoint the weak places and you concentrate on your strengthening effort there.
Yeah, it's absolutely right what you said. And just from my point of view, you know, in the building, the house estates right now, they should follow the standards, which means also resistance for possible earthquake. But we know how it is sometimes in reality, or based on that, what was in the previous time. We can't, let's say, predict is it, let's say, well done or bad done or otherwise. So your activity, your data, your analysis could give the local authorities a real picture.
Sure, yeah. It's possible, like you said, a very new building, a freshly built building. It is possible by using this method to estimate, does it behave exactly as it was designed, or there are big deviations in what is designed and what the building actually is. You can do this. And it is important because if the design natural frequency of the building were, for example, 2 hertz, and you measure it, and it turns out to be 1 hertz, significantly lower, it means that there are severe discrepancies in the structure. It would mean that, definitely. So
it could be recommended to do even the test during the construction time.
After the construction, no, during the construction time, it's difficult to get anything from that. But after the structure has been completed, it's good to do a check at least for the natural frequencies of the building, and it's also good to put this somehow into the legislation, because otherwise nobody would do it just by their own will. Very few people would do it.
Yeah, I agree. Thank you very much.
Okay, thank you.
Bert, any questions?
Yes, I have a question to Mr. Nikola Todorov. I don't know, sir, if you are still with us. Sir Nikola Todorov, are you here with us? Okay, so I'm obliged to skip this question, and maybe afternoon I will be able to pose this question.
Do we have Mr. Stefan Georgiev with us online?
Mm-hmm.
Mr. Stefan Georgiev, can you hear us? It is muted. Okay, maybe it seems that all online participants started lunch already, and we are the only obstacles to them. So, we have also the Mr. Vasco Galadov here. Vasco, can I ask you, what is the time, the possible time prediction of the high wave? You told me that you can estimate, for instance, that the high wave is incoming to the Black Sea coastline. Do you have a time prediction? Is it in the 1, 2, 3 days in advance?
Yes, presently the operational wave prediction here in Bulgaria is for 72 hours.
72 hours.
Which is fairly enough, but this can be extended without any problems up to, let's say, 120 hours or 5 days, or even more.
So I can assume that, for instance, the local authorities of Burgas or Pomorie, they could get this information, and they can at least inform the citizens or alarm the rescue teams.
Oh, yes. Yes, such a system functions.
Okay.
And warnings are available in the European Meteor Alarm System for coastal events as well. Yeah.
Maybe this could be also, good for even for Mayor of Plovdiv. Who knows, in next 50 years, maybe the seaside will be in Plovdiv, not in Burgas.
Fortunately, we don't expect a biblical flood.
I hope not. I hope not. Okay. From your presentation, I saw that the higher noticed waves were around even 9 meters, but it was very, very seldom. Yeah? But the 5-6 meters are quite often, yeah?
Yes. 5 meters can happen, let's say, at least once per decade.
Per decade?
Per decade, yeah.
It's usually during the winter time, yeah?
For instance, the last 2 winters, we did not have such big storms, but the last ones that were clearly above, let's say, 4 were 2012, 2014. If I remember correctly, back in 2016, there was A big one, however, it was more influencing Turkey rather than our coast.
Yeah, I can assume that this kind of waves, for sure, they will be very dangerous for the shipment traffic on the sea, of course, but also for the coastline. Do you have any, from historical background, which part of the coastline of the Bulgaria is the most vulnerable for such waves? Is it the southern part or northern?
It's interesting to mention here that if we look at the infrastructure at the coastal towns, everything that was built, let's say, before the first half of the 20th century, was more or less not vulnerable. I mean, the towns of Varna, Burgas, the smaller towns, they were usually built high above the sea.
Okay.
So in some sense, the people back then were clever enough to build their towns to be resilient to the winter storms. What is going on nowadays is building of tourist infrastructure without taking into account at all the possibility for storm events. I mean, building of hotels on the coastline.
You know, they have other perspectives.
Yeah.
To be closer to the sea.
Yes.
Especially in the first row on the Sunny Beach, for instance. Yeah.
Therefore, the vulnerability to the storms is not just the storms themselves, it's also the...
You know, if the heavy storm is one per decade, some of them even don't know it. You know?
From my experience, 2 or 3 years ago, there were claims that some owners of a hotel were not properly warned about a storm. What we found that, yes, there was no warning because the event was something that happens, let's say, more than once every year. What was the story? They decided to build a hotel on the beach, and they were highly surprised when the hotel was damaged already during the first winter of its existence. So yeah, the areas by default in our coast are not vulnerable. It is the people that building and responsibly the infrastructure.
I'm wondering what insurance company will say on that.
Excuse me, may I also add something?
As far as I know, in many cases they refuse to
pay.
To make the insurance at all.
At all.
Yeah.
That's just taking opportunity to thank you very much for your contributions, for the presentations, and for very vulnerable information you provided to us. So I would like to present you this certificate.
Thank you very much.
Thank
you.
And also I would like to ask for our second face-to-face speaker.
Please come up.
So thank you very much for your presentations and all the information you provided to all of us. Thank you very much. Thank you, sir.
Thank you for the opportunity.
Thank you. Thanks, sir. And now I have one announcement which is related to our icebreaker. So we have a change. The icebreaker will take part tomorrow. It means 7th of June at 5:30. So not today, but tomorrow at 5:30, and it will take place in the Astoria Hotel. And now there is a time to take the lunch break, and we will see each other again in this auditorium at 1:55, so 5 minutes before 2. Thank you very much and enjoy your meal. Thank you.
Thank you.
Jest tam. Nie, Darek. Good afternoon again, and thank you very much for being on time after the lunch break. And I would like to invite our another briefer, who is Dr. Lilia Bocheva. Thank you very much. And we are ready for your presentation, ma'am.
Yeah, it's raining outside. Maybe there will be the hail as well.
Yes.
It was hail.
It was hail.
2 times.
Today?
Yes. Before 20 minutes, maybe.
Mm-hmm.
Okay.
To put another slide.
This one. Okay. Hello, everybody. My name is Lilia Bocheva. I am a director of Department of Meteorology in National Institute of Meteorology and Hydrology in Sofia. So my speech will be about recent trends in hail precipitation for each of administrative districts in Bulgaria. And it's I do this research with my colleague Vouchu Popohristu from the Department of Climatology. You know, well, maybe slowly. Excuse me, but I tried. So, how you know from the morning speech of my colleague Stefan Georgiev, Bulgaria is a country with very often hailstorms. It's situated in this part of Europe, which is with highest frequency of hail. And many countries of this area, the damage is caused by hail precipitation is a significant part of damages from natural disasters. In general, here you can see the charts from my colleague from European Severe Storm Laboratory, which dedicate this. Also, here is presented the number of severe hail larger than 2 centimeters. Unfortunately, in Bulgaria, we didn't measure the hail size, so we have no data about this. The diverse terrain of Bulgaria additionally favored the conditions that characterized it as one of the most hail-stormy countries in Europe. And during the last 20 years, the frequency and severity of these events increased, and also the damages produced by individual hail events. Here I present some photos. First of all is from July 2014. You remember in Sofia it was a very large hail, and the duration of hailstorm was more than 25 minutes. So a great damage caused it for the city. And the other ones are from the previous week in Rhodops and in central South Bulgaria. You can see the size of the hail. The damages on roof and agriculture is great and very dangerous. The aim of our study is to present the current changes in the frequency and distribution of hail precipitation, which is summarized for each administrative district of the country. The study was conducted on this principle because the summarized results are crucial in assisting the state and local authorities in developing contingency plans and policies for adaptation against the climate change and regional level. And we have many requests about this type of study from different parts of Bulgarian authorities. The present study analyzed the time-space variation of hail events in each of our administrative districts for the period 1991-2020. The monthly, seasonal, and annual frequency of hail events, as well as climate normal for days with hail precipitation, are calculated for each meteorological station and summarized for all districts. Also, the comparative analysis of annual hailstorm frequency for single event for 30 years period is obtained. Two periods are previous one, which was recommended by World Meteorological Organization for calculation of climate normals, and the recent one. So we choose one station from the district with a good data row. So it's on this map all working station from the meteorological network of Bulgaria is presented. All data for existence of hail precipitation events from the meteorological records of National Institute of Meteorology and Hydrology for the period 1991 and 2020 are used. And for the previous, for the long period, 28 representative stations, one from each district. It's mentioned by S1 to S28 are used. The stations are selected in accordance to continuity and quality of their time series. Days with hail are reported for each station in which at least one such phenomenon is registered between all the day. The hail precipitation is recorded only when they occur in the limited area of the weather station. So they many of them are underestimated because of that, because the normal meteorological network is not supposed to be a better one for estimation of such rare event. The data obtained from each station is analyzed, and for the long period, the monthly, seasonal, and annual number of days with station, one from each district. It's mentioned by S1 of days with hail precipitation for each district for the period of interest are estimated using specialized procedures in SQL environment. For seasonal analysis, we divide the year on two parts, one half from April to September and cold half from October to March. The statistical significance of tendencies at 5% significance level for the first period are estimated by means of Mann-Kendall test with sense slope estimator, and for comparison of two rows, 30 years rows data for each station, the novel with Poisson distribution again at 5% significant level are used. And here is some of the data. It's climate normals, which is summarized for each district of Bulgaria. I bought them in a different color. So the highest frequency of hail days in one station is in Sofia city, which is normal because it's in southwestern part of the country with huge mountains and it's very favorable air condition. And the another one, which is for the first time, it's different from the previous researchers, is Yambu and the region in Forodops, where the frequency of these events become more usual nowadays. We can see that for all country during the whole period of interest, this 30 years period, there is 2,510 days with hail precipitation at all, and they have their variation year by year for all country have a negative statistically insignificant trend. The same trend is put on cold half and warm half of the year. So in cold half of the year, we have a statistically insignificant upward trend. The decreasing tendency in distribution of hail precipitation days is observed in 11 administrative districts, and half of them are situated in West Bulgaria. All negative trends are statistically insignificant, with the exception of only one in district Pazardzhik, which is central South Bulgaria. In the other 17 districts of the country, the number of hail days increased during the period 1991-2020, and this positive trend is statistically significant for 6 of them. The distribution of hail days in over the all districts in the country is presented here for warm and half of the year and for cold half of the year. So you can see that more than 10% of hail events are in some districts in cold half of the year. And they're mostly in areas with continental Mediterranean climate. The most common are autumn and winter days with hail in Eastern Rhodes. In Kyrgyzstan, it was about more than 24% of hail events. In Strange and near the Black Sea coast also, there are a huge number of these events in cold half of the year. And also in the southernmost region of Bulgaria, which is influenced from Mediterranean air masses in Volgograd district. Here it's present the statistical estimation. It's a probability only is presented here in this table. Of significant trends are in dark red and dark blue, and we can say that obviously in winter time the trends in a rise of number of days with hail events is spread all over the country. You can see these pink colors here. So what concerns the year, we have 3 districts from North Bulgaria and 3 districts from South Bulgaria with significant trends in upward trends in hail precipitation, only 1 downward trend in Pazardzhik. So the hail events become more frequent in winter time mainly all over the Bulgarian districts. Maybe it's a good reason to make a chance to have rather information not only for warm half of the year but also for cold one. But it's not depends of us because the radars in another agency. Here is presented the comparative analysis of annual distribution of hail days during the 2 periods for the representative station from each district. These stations is mainly the main cities from the districts, but also from some of them we chose the another one station because they have better data rows. And we can say that 7 stations bolded in this table have a statistically significant increase for frequency of hail days. In North Bulgaria, there are 5 of them. In North Central Bulgaria, Pleven, Gabrovo, and Veliko Trnovo, and in Eastern, 2 of them, Târgoviște and Razgrad. And in South Bulgaria, Yambol and Haskovo, which confirm the other show in previous slides information that in Rhodops the number of hail events increased recently. It's a comparison of 2 periods, so there is a normal trend for this event. The largest increase is in Haskovo, and we can say that nowadays we have 2 times more days with hail compared to previous period. And it's confirmed with the fact that the Hail Precious Agency put the new radar nearby the Haskovo, so they protect this area now. Comparative analysis of annual distribution of hail days is presented here for annual and seasonal basis, and you can see that the significant increase in cold half of the year is most pronounced in North Bulgaria than the other side, and the differences from for new period in comparison to old one is not so remarkable in southwestern part of the country, which is here. I don't know. The last S on our graphs. And in conclusion, the highest annual frequency of hail days for the period 1991-2020 is in district Sofia city and in Yambol, followed by Haskovo, Târgoviște, Lovech, and Sofia district. The smallest number is in northeastern Bulgaria, Dobrich, and along the Danube River. Vidin, Ruse, Lom are the same. More than 10% of all hail days are in cold half of the year for the regions with continental Mediterranean climate, and for most of the country, the trends are towards increasing the number of registered hail in winter time, but the trends are mostly statistically insignificant. Man-Kendall test revealed a significant increase in annual hail days for 6 districts and significant decrease in one of them. and the annual regime of hailstorms days for 28 representative station is compared for 2 periods. For 25 of them, the increase is frequently of hail events is observed, and for 28%, it is statistically significant for 5 districts from North Bulgaria and for 2 districts from South Bulgaria. And thank you for your attention.
Thanks a lot, Dr. Bocheva, and we will have the opportunity to pose some questions after all, but now I would like to invite Dr. Natalia Andreeva.
Thank you very much. I'm here. Hello to everyone.
Can you hear us? Sorry.
Yes, I can hear you. Can you hear me? Hello? Hello?
Yes,
We can hear you.
Oh, you can hear me. Okay. May I start the presentation and I will switch off the video for better streaming?
Sorry, we cannot hear you.
Who can hear me? Who cannot?
Only in the studio probably they cannot hear you, but we can hear you.
So I don't know what to do in this case.
Sorry.
Hello?
Przechodzimy do następnego punktu. Dr. Andreeva, can you hear us?
Yes, I do. But do you?
I think we can see you, but we can't hear you.
I don't know. Maybe I should leave and
Ale na zielono było, widzisz?
A może my jesteśmy?
Nie. Teraz zniknęły.
Hello?
I don't know, I think it will be good to start the presentation.
Natalia Andreev. Jest kamera zielona.
I don't know, can anyone call them or connect them somehow? I don't know.
Okay, now we can hear you.
Oh, okay. Let me share. I will switch off the video and share the screen. Thank you. Hello to everyone. My name is Natalia Andreeva, and me and all the authors of this research, we are working in the Institute of Oceanology in Varna, Bulgaria. Today I will speak about assessment of vulnerability to storm-induced flood hazards in a large bay. As you all know, coastal areas are highly dynamic and complex multifunctional systems, which include a wide number of socioeconomic activities. On the other hand, coastal flooding is a major natural hazard caused by low probability and high impact hydrometeorological events, and are regarded as one of the most dangerous and harmful disasters endangering human life and occupation. The aim of the present study is to assess in probabilistic terms the magnitude of storm-induced flooding hazard along Burgas regional coast and to identify susceptible coastal sectors or hotspots. It was done using the Coastal Risk Assessment Framework, which is a screening process that allows delimitation of susceptible along-shore sectors by assessing relevant hazard intensities and extents and potential exposure vulnerability of different receptors. It follows the index-based approach as it combines several hazard and exposure indicators into a single index, which allow a rapid comparison of coastal sectors. The result is assessment of the potential risk in holistic terms, as the evaluated risk is relative and does not provide information on the actual expected losses. As I said previously, the study site is located along the regional coast of Burgas and comprises the coastline of municipalities of Pomorie and Burgas. Main characteristics of the study site are coastal length of approximately 90 kilometers with variety of coastal types, the presence of the largest in Bulgaria complex, lake complex or Burgas lakes or wetlands of varying salinity, protected areas under Natura 2000 and directives for habitats and birds. The socioeconomics we identified along the coast include seaside and spa tourism, port and related commerce and industry, coastal harbors and marinas and fishery, as well as outworks of Pomorie and Burgas. In order to estimate the coastal flood hazard, as a first step, the coastline of both municipalities was divided into 71 sectors of average length of 0.21 kilometer. But at this stage, only 48 sectors were evaluated due to lack of topographic and shallow water bathymetry data. So to estimate the coastal flooding hazard, first we needed hazard intensities. And for their calculations, we formulated a parameter which we called total water level, which is a superposition of wave-induced run-up and storm surge. To this end, we needed wave data and sea levels. So the study followed the response approach, which the main idea is to identification and selection of large number of storm events. To this end, 200 extreme storm events were identified using hindcast wave data and accompanied by sea level daily measurements covering a period of 69 years. The next step to estimate the parameter of the total water level, the wave-induced run-up was calculated along 121 profiles, which were selected in the coastal sectors. And the run-up for sandy beaches was calculated using the Holman model, while for rocky and artificial slopes, the Evertop formulation was used. After forming the time series of the total water level, it was subjected to extreme value analysis to find that the best fitting distribution is generalized extreme value distribution. And with the help of this distribution, different return periods of the total water level were identified. For instance, for 20, 50, and 100 years. But here we present the results only for 50 years return period. The next step was to calculate the hazard extent. As for the fast rising hinterland slopes, the bathtub approach was implemented. And for low-lying lands, the overwash extent was used. As a hazard indicator, we use the weighted total water level, which combines the values of the total water level and areas of inundation within each sector. The results were ranked from 1 to 5 by natural breaks data classification method. These are the results of the flooding hazard indicator along the sectors of the study site. As I said, the sectors which are not assessed are colored in gray. So highly susceptible to flooding are 11 sectors. It's very high, around 8 sectors. These are localized along the coasts of Ahiloi, Pomorie Spit and town of Pomorie, Burgas City beaches, Crăimorie and Cengheneskele Bay. The 8 sectors with very high ranks may be divided into 2 groups, main modified beaches, which include Ahiloi, Pomorie, Burgas and Crăimorie, and one site, protected site, Cengheneskele. The next step was to evaluate the exposure indicators, which were connected with different types of receptors. Receptors like land use, population, transport, utilities, and business. Each of these indicators was ranked from 1 to 5, showing the lowest and the highest level of exposure vulnerability. And finally, all of these exposure indicators were combined into single overall exposure indicator for the same region. The land use indicator was calculated for each coastal sector within the inundated areas. For this purpose, we used the national perennial land cover data from 2018 and aided by the refined coastline updated to the year 2020. Some of the perennial land cover data classes were merged to facilitate the evaluation. And after application of the formula, the land use was assessed in each coastal sector. The results show that is higher ranked 4 sectors within Burgas beaches, Burgas shipbuilding, and protected area Mandrapola, as well as Primorje. As very high was ranked only 1 sector in the southern industrial zone of Burgas. For the assessment of the population indicator, we used the social vulnerability index, which actually assesses the socioeconomic capability of the population living in a given area to cope and to recover from disastrous event. And this indicator was estimated on a municipal level using data from census 2011. In order to get a statistical reliability, assessment was done for 32 municipalities falling within the coastal regions of Dobrich, Varna, and Burgas, and the resulting values were ranked from 1 to 5 by natural breaks method. Results show that population of Primorje has low social vulnerability, and population of Burgas has very low social vulnerability. Since the data were from 2011, we saw more updated data to justify those results. And they were supported by the report Regional Profiles Indicators of Development, classifying the socioeconomic development of Burgas for year 2021 as good. The next indicator for transport was assessed again for each coastal sector within the inundated areas. To this end, we obtained georeference terrestrial networks classes and roads classes from master plans of Primorje and Burgas. Additional information was acquired from WorldStreetMap and OpenStreetMaps. An evaluation and ranking was done according to the rules using the national road classification. It turns out the predominance of low and very low ranking across the sector is evident. Only 2 sectors are ranked as moderate, and concentration of high ranks is in the premises of Port Burgas due to high density of network relevant to port activities with regional and local importance. The principle for assessment of utilities was the same for each coastal sector within inundated areas, as utilities were regarded water supply, electricity, telecommunication, emergency, and medical centers. The data again were acquired from master plans of Primorje and Burgas and Wikimapia and OpenStreetMap and aided by field surveys and desktop research. Results show that predominance of very low to low ranking across the coastal sector, as the highest assigned rank is moderate, associated with utility assets related to Primorje, Burgas Southworks, and Port of Burgas. The final exposure indicator concerns business. The business settings identified at the study site according to the methodology are beachfront urban area, port and related commercial and industrial zones, coastal harbors with or without marina, and related urban areas. Data on business assets, their types, numbers, and economic significance was gathered during field surveys, desktop research, and Wikimapia and world imagery. Evaluation was based on business presence and significance of economic activities, while ranking was according to ranking rules presented within the table. Results suggest show that as higher ranked 4 sectors within Pomorie and Burgas Southwarks, as very high 10 sectors related to tourism in town of Pomorie and activities of Port Burgas along with shipbuilding and ship repair plants having economic importance. And finally, all those 5 exposure indicators were combined into a single exposure indicator by geometric mean. And results show that high exposure vulnerability have 9 sectors. As very high are ranked 4 sectors. They are related to seaside tourism in Burgas, Pomorie and Crăimorie, and port and industry and commerce related to Burgas Southwarks, port and shipbuilding and ship repair activities. And at the end, by geometric mean, we combined the hazard indicator and the overall exposure indicator to obtain coastal index for each sector. As you can see, the hotspots candidate are sectors with the highest rank of 4 and 5. These are 13 sectors, as 8 sectors are with rank high and 5 sectors are with rank very high. They can be grouped as seaside recreational areas at Aheloi, Pomorie, Burgas and Crăimorie, and in the industry and commerce activities for Burgas Southwarks, Burgas shipbuilding and ship repair activities. In conclusion, considering the flooding hazard, 11 sectors have high susceptibility and 8 sectors are ranked very high. 2 groups of coastal stretches can be identified within the red sectors, man-modified beaches and protected sites. The first group sectors are scattered across the study site and are under anthropogenic pressure due to presence of coastal protection structures. The wave exposure of these sectors varies from exposed for Aheloi and Pomorie Peak to moderately exposed for Burgas and Crăimorie. The estimated total water levels range between 4.9 meters to 4.6, being among the highest, leading to inundations beyond the rear beach line and posing threat to human activities. In the second group falls the sector located within Chengenescele protected site, represented by low-lying wetlands, and with estimated total water level of 3.6 meters, causing large inundation. The overall exposure indicator is predominantly controlled by different business settings and affected land use, and to lower extent by transport and utility assets. The land use with highest exposure is beaches, followed by nature conservation and wetlands. Having in mind the strong dependency of the seaside tourism on coastal location and adjacent beaches, and that these assets support and determine tourism revenue within the regional economies, tourist business is indirectly affected by flooding hazard. Analysis suggests that for hotspots allocated to seaside recreational areas, the coastal index is almost equally driven by flooding hazard and asset exposure, while for industry and commerce hotspots, the exposure in terms of business presence and affected land use have stronger influence. Thereby, the most vulnerable to storm-induced flood hazard are the coastal areas at Aheloi, Pomorie, and the inner Burgas Bay, comprising socioeconomics with regional, national, and international importance. And finally, the present study should be considered as initial since they don't include assessment of flooding hazard vulnerability for all predefined sectors. Thank you for your attention, and here I present the project within which all this work has been done. So thank you.
Thank you very much, Dr. Andreeva. And now I would like to give the floor to Ms. Nadia Miteva. Yeah.
Nadezhda.
Sorry, Nadezhda.
Nadia is better, yeah.
This is for the
forward. Okay.
Great.
Okay, hello everybody. My name is Nadezhda Miteva, or for short, Nadia. I am part of the Resilog project research team. I'm a representative of the Balkan Institute for Labor and Social Policy, and together with my colleagues and co-authors from the Bulgarian Red Cross, we would like to present you today with some preliminary research, or in other terms, a feasibility study of our Tetovo trial that is being conducted within the ResiLog project framework. Before I start, a bit of background. In 2020, during the first ENVIRORISKS conference, we had the pleasure of introducing for the first time the ResiLog project. And at this point, we were in the middle of the studies phase of the project. And now we have already the tools, software, and paper-based, and the communities that are trying out those tools. So the results that I'm going to show you here are sourced from the field, but they will also evolve during the next part of the 2022. Year 2022. Okay, so what is the ResiLog project? It's a research and innovation project funded under the Horizon 2020 research program. As the name suggests, it aims to make local communities more resilient to any type of hazards, through providing them with the right tools to assess their resilience. So the tools that I'm going to show you in a bit are actually strategic resilience assessment tools that are made accessible to people from local communities that may be either experts or non-experts, depending on the needs of the community that are identified. The overall goal of the research project is to provide communities with the ability to create new strategies to gradually improve their resilience. As you see below in the slide, this is the change story of the project. As I mentioned, we are in the actions and outputs phase of our efforts. The trials that we are having are conducted in 4 separate places in Europe, with Tetovo in Rusa municipality being one of them. And here I can already demonstrate part of the tools that we have developed within the project. I am showing you this because together with the trial setup information, we will be able to grasp these preliminary results from the feasibility study. So on the top left part of the slide, you can see the dimensions, indicators, and proxies framework, or DIP framework, as I will call it from now on, that has 6 separate dimensions that we established as the societal dimensions, capturing very different facets of resilience within each community. This framework, DIP framework, is the result of almost 2 years of research, and it has been partly co-created with communities. So it's research-based and also civic science-based, if I can put it so. The indicators and proxies for each dimension vary in number and also vary in format. So they can be qualitative, they also can be quantitative, and they can be fed with objective data and with expert estimations if objective data is not available or not obtainable at all. In the upper right corner of the slide, you can also see our platform, which is the software tool actually hosting the DIP framework. This is the ResiLog platform, and it is a tool, open sourced and open registration tool that can be used by local communities if they wish to set up a profile for themselves and wish to also assess their own resilience against each of the dimensions and the indicators proposed. This tool, if some of you have conducted research or are acquainted with, can partly resemble the UN Cities Resilience Scorecard, but it's different to a greater extent in that it offers the ability to create resilience scenarios across time and also across space. So there is a comparability opportunity there. How the tool actually works, one of our participants in the trial said that they find it similar to the mathematical optimization method that is used for strategic planning research. How it works is first to set up the proxies and indicators that are relevant for a given local community, then to feed the proxies with data, and in the end, we get the visualization that you see at the bottom right part of the slide. There are blank spots there because the graph is not fed with data, but where it is, so where the proxies values are available, you can see in a semaphore type of visualization that there are some better performing dimensions and some worse performing dimensions. How this assessment is actually done is that before feeding the platform with real life data, as I said, either objective, administrative, statistical, etc., or subjective data, a panel of experts from the local community that in the best case scenario includes representatives from local authorities, citizens, topic experts like emergency and first responders, and medical services, for example. They sit around the table and they determine for each proxy the minimum and maximum target values of the proxy, its direction, meaning how it impacts the resilience of the local community, and its relevance for the resilience of said community. And finally, in the bottom left part of the slide, we also have a visualization of the ResiLog app, which has it's a small picture, but it's quite a responsive app. It has two main functions. The first one is for the people who operate the ResiLog platform and ResiLog tools to submit surveys to the local community when they wish to collect data from the field for indicators, for example, from the social dimension, where we measure the extent to which the community feels safe during before disasters, during disasters, and after. And the second main function of the app is to serve as a sensing device for Wi-Fi networks, Bluetooth connections, and geolocation if this is preferred by the community. So that's part of the background. The second part that focuses on the trials that we have is a slide that you see that briefs the profile of our Bulgarian trial site, which is Tetovo in Rusa municipality. Something that I actually forgot to mention is that the third tool that we have within the ResiLog array of tools is a sentiment analysis tool developed by the Josef Stefan Institute in Slovenia, but we are not going to trial this particular tool in Tetovo because it's not able to. First of all, it works with Twitter data, which is a social platform that is not very popular in Bulgaria, and also there is a Tetovo in North Macedonia that is far more famous, and the sentiment analysis tool cannot distinguish between the results from the two sites. And that being said, Tetovo is a village that has roughly 2,000 inhabitants as of 2021. And it has two main hazard risks that were identified by the local community as the most relevant, so as the ones that we can work with during the resilience assessment. These are snowstorms that usually happen almost every year, and that cover one of the main road that connects Ruse with Tetovo village, and it makes it impossible for ambulances to travel to that village. And wildfires are the second risk. They are important as a risk mostly for the business and the economic development of the village, because the agricultural sector is the most developed economic sector in the village. as one can guess easily. With this, I present you in this slide the preliminary results from our feasibility study. So to understand the numbers, I hope you can see them well. If not, I'm going to summarize them in a bit. We work with a concept in the local context that is, let's say, developed within the ResiLog project. These are local resilience teams. What are those? They are a team of local experts designated by the community and by researchers from the project that work together in order to assess the resilience of the communities participating in the project and to come up with strategies for improving this resilience. The trial process is set in 4 stages. The first 3 are actually capacity building. So they are introducing the local resilience team to the tools that we have, then collecting the data necessary to feed the tools with data and come up with the assessment, and then conducting a dry run and 2 pre-dry runs before actually going out to the larger community with a preliminary resilience strategy that is assessed within a European awareness scenario workshop. So these results are all based on the first stage of the trial, and they assess the conceptual, technological, and strategic feasibility. The numbers are very, very low, so actually the results are rather more qualitative than quantitative, because this is a survey that we conducted among the participants from the local resilience team and not the larger community. What is interesting to note is that each dimension of the feasibility evidence is on the positive side, which is encouraging. It's not at the top of the range, so it's not a +2, because many of the participants identified the need to adapt and to introduce or to discard some indicators and some proxies from their community resilience assessment in order for the framework to work. What is also very interesting to note here is that in the strategic feasibility dimension, the participants, even though they are focused on Tetovo, they recognize the fact that Tetovo is not working with a strategic tool in Tetovo is not the same as it would be working in a Rusa municipality. That is because by default, so by law, administrative units like town halls, which is the case of Tetovo, don't have the same administrative power as a full-fledged municipality has. Even so, the tools can be used in rural areas. Thank you. And what they need for sure is to also have the exact data to feed the system. That is very important to note from my perspective, because something that we clearly lack as researchers and as practitioners are public data at the NUTS 3 level for any kind of research. I don't know if you would agree, but this is something that I almost on a daily basis encounter in our work. So the final part of this feasibility study is a SWOT analysis that covers both the developments of the Tetovo trial so far and also some opportunities and threats that we identify for rural areas that would hopefully in future also work with the ResiLog tools. What I mentioned for the data is completely valid. What I would also want to mention is that for sure, any type of tool that is aimed at increasing the resilience in local communities needs to be accessible, both in technological terms, meaning for the community to have internet, to have the correct language in which they can work, and also to have the ability to adapt and to come up with proxies that are relevant for their own communities. Another part that I would also want to underline is that the tools are just tools. So if they don't have the right people for them to be worked with, they will not deliver the right results. So if a local resilience team is formed within a local community with the aim to both assess the resilience of the community, but also to proliferate the culture of increasing resilience in said community, it's good for them to be from different backgrounds and from different parts of the stakeholder array. Thank you for your attention.
Thank you very much, Ms. Micheva. And now my idea is to do 2 online presentations, and then it will be followed by the question and answer session and also a coffee break. So if, I don't know if Dr. Karina Górska-Rożej and Dr. Wiesław Krzeszowski is online with us right now.
Yes, we are.
Dr. Górska, can you hear us?
Yes, I hear you. I am by the computer.
We can hear you as well, the online participants.
Can you hear me?
Okay, so in this case, let's take a coffee break now, and we will find a solution to get online. But we cannot hear. Dr. Górska, can you hear us?
Yes, I hear you.
Okay, thanks
you hear
a lot.
Me?
Dzień
Can you
dobry.
hear me?
And
Dzień
we are
dobry.
ready to hear the presentation.
Sorry, have we a break?
No, if you are ready with the presentation, you can share the presentation and we can go ahead.
Okay. Just a moment. Can you see my presentation?
Yes, we can see.
Okay, so let's start. Yes. Hello, my name is Karina Górska-Rożej. I work at the War Studies University in Warsaw, Poland. I'm an assistant professor at the Management and Command department. I prepared this presentation with my research partner, Wiesław Krzeszowski. The title of my presentation is Building Community Resilience at the Local Level. Okay, the security of local communities is primarily expressed in meeting the basic needs of the society, both in the subjective and objective aspect. The sense of security in society allows for its development and cohesion. It also translates into economic development and the attractiveness of a given region. It also influences the formation of specific identities in inhabitants and specific bonds between them. These elements contribute to building a community that is capable of efficient and effective creation and protection of
of values and goods. Managing the safety of local communities is also making the society aware of the threats to which it is directly exposed and preparing the inhabitants of a given territory for their appearance and changes that will occur with negative events. We choose this topic because we believe that local communities need to increase the level of adaptability in order to deal with sudden, unexpected changes and efficiently return to normal functioning. We argue that the foundation of safety management is a holistic view of the threat resilience process, and that this process should start with the community at the local level. The subject of research in this presentation is community resilience at the local level. The main aim of the research was to justify the need to build community resilience to threats at the local level in Poland. The research problem was generated in the form of a question: is there a need to build community resilience to threats at the local level, and why? A more detailed description of the methodology can be found in our scientific article published after the conference. How is the resilience indicated in the title to be understood? The attention paid to the concept of resilience is the result of increasing uncertainty and changes in the nature of threats. Resilience focuses on the following aspects. The first, social aspect, I mean individuals, groups, cultural, political, or economic systems. The second aspect is economic. I mean use of private funds to respond to threats. The third, natural surroundings. Yes, it is a natural aspect. The next, physical aspect, for example, technique, infrastructure, technologies used. And the last one, institutional, I mean public administration. When perceiving this concept in a social aspect, it is worth pointing out that it combines three elements. The first is building community with other members of society. The second is using and learning from the experience gained. And the last one, improving existing social practices. A resilient society understands and is aware of the risks it is exposed to, prepared for their emergence and the changes that will occur with negative events. Accordingly, resilience is associated with the ability to deal with sudden, unexpected changes and a smooth return to normal functioning. In order to determine the resilience of a given local community, it is first of all necessary to diagnose and explore the level of preparation and ability to respond to specific threats among individual members and the entire group. Resilience is also dependent on geophysical conditions, event description. This is duration, this is speed, intensity, and frequency of occurrence. The current situation of the society, for example, migration crisis, epidemic, of course, unemployment, increased aggressive behavior in public places, crime or social unrest. Resilience should increase with the learning process that begins after the emergence of a given threat. Adaptation is also seen as adjusting the behavior and characteristics of a given system in order to increase its ability to deal with external threats. It allows to reduce the risks associated with those threats by reducing social vulnerability. Adaptation is important because it is part of resilience and includes the ability to adapt to changing external and internal conditions, thus enabling development in line with existing trends. Social adaptation is activated with the help of adaptive abilities. They contribute to increasing resilience and reducing vulnerability in local communities. Adaptation abilities are also directly related to efficient and effective management of the safety of local communities because they allow individuals and groups to adapt to potential threats. They relate to changes in the administrative structures of local community management, allow for appropriate social communication, the process of social education, building social capital, or also strengthening the economic opportunities of the society. In the connection with the above, it is worth mentioning the components of adaptability, which include the first economic development. I mean professionally conducted risk analysis that allow to reduce the negative impact of various types of undesirable events on the functioning of the local community. I mean diversity of economic resources, for example, capital, for example, labor, technologies, and I mean even a distribution of resources. The second, I mean information and communication. Including media responsibility, selection of appropriate methods of providing information, or willingness to help and not only to arouse sensation. The third, social capital. I mean, for example, social support, cooperation, citizen participation in the activities, or a feeling of belonging to a group, attachment to a place, or leadership and rules in a society. And the last one, interpersonal competences. This is ability to cooperate, problem solving together, listening skills, the ability to empathize with the other person, maybe, or a flexibility, creativity in interpersonal contacts. The following ways to build resilience to threats can be listed. The first, supporting all initiatives implemented to increase the level of safety in a given area. The local initiative is one of the tools for the implementation of tasks, solving problems reported directly by a specific local community. I think about, for example, initiative for the elimination of crime, introducing monitoring in places where the most events of this nature have been recorded, or in places where the community is afraid to stay. The second initiative is, for example, education initiative on counteracting the spread of the SARS-CoV-2 virus, providing reliable information on vaccination against COVID-19. The second way is providing access to social capital for all members of a given community. Free understanding of social capital concerns the level of trust among a given group, the nature of relations that are formed within it, as well as the ability and willingness to cooperate. The inclusion of the local community in the planning process and preparation of tasks that directly concern that community means that each individual has access to the described capital. Thanks to this, the resilience of the local community grows as its a level of autarchism increases. The third, expanding and increasing the quality of economic resources of a given community. It is primarily the minimization of the risk of destructive phenomena and the improvement of the methods of their dissemination that depends on expanding and modernizing these resources. The fourth, increasing the level of civic activity. This is a very important point in my opinion. An active citizen is involved, for example, in the process of social participation, attends sessions of the commune council, reporting problems concerning a specific social group. Participates in government elections, monitors the activities of elected authorities, and decides about the matters of the community of which he is a member. Civic activity is an important element in meeting the threats. Unfortunately, the empirical research conducted shows that in many local communities occupying various areas in Poland, we constantly have a problem with a mediocre sense of civic responsibility, and this should be our duty, in my opinion. Where then should we look for the reasons for this state of affairs? Probably in the low level of civic education and low level of civic competences of the community at the local level. And the last one, information management, conducting training in the field of potential threats, making the local community aware, sensitizing each individual to specific elements of social coexistence, increasing vigilance and interest in what is happening around us, to a large extent shapes a resilience of the local community, and as a result allows for an efficient adaptation process in the event of changes that the place in the environment. Building a social culture is also an important element too. Summing up, it is worth indicating the most important areas that will enable building or increasing the level of resilience to threats in communities at the local level. The first is education. Its core should be activities consisting in providing information on how not to escalate threats. In addition, an important assumption should be to increase social awareness of potential threats, understand the nature and their possible range. It is also worth equipping society from an early age with knowledge about how to behave in the event of a given threat. The second area relates to communication, establishing and maintaining social dialogue. Each unit that contributes to a given local community should have equal access to knowledge, information, and data. Members of such communities should be willing and understand the need to share information they have and jointly make decisions about their safety, functioning, and development. The latter translates into the third important area of cooperation and collaboration. We encourage you to read our article published after the conference. Thank you to your attention.
For your comprehensive brief. And now I would like to give the floor to Professor Dimitar Stefanov. Sir, are you with us?
Yes. Hello. Dear colleagues, the title of our presentation is Assessment of the Effects of Strong Earthquakes on the City of Russe. We are from the National Institute of Geophysics, Geodesy and Geography, Bulgarian Academy of Sciences. In the last few years, a number of earthquakes have occurred in Balkan Peninsula, some of which in Albania and Croatia have caused significant damage, social and economic losses. The efforts focusing on disaster management and disaster risk reduction have become increasingly important worldwide. Scientific knowledge about the sources of earthquake ground motion, as well as the vulnerability of the building stock to seismic excitations, make it possible to more accurately determine the adverse effects of strong earthquakes. The seismic hazard for city of Russe is controlled by Brancheia intermediate depth source in Romania that is located at about 150 kilometers to the north-northwest from the city. The process of gathering input data in a format that is appropriate for processing and analysis is delicate and responsible. Over the years, several public databases have undergone numerous updates, changes, and even deformations anywhere. So it's very important to create a good database. The graphic database is connected in two directions with the textual basis for the building stock through a cadastral identifiers of the individual buildings and properties, thus providing the possibility for the future visualization of different thematic map materials. To help this, an orthogonal coordinate division zoning of the graphic parts is constructed by means of quadrants 450 meters side. The network is individualized by alphanumeric identifiers. At this figure, you can see the network of numbering for the map of city. And for the right side, you can see only demonstration for one part of the one quadrants. This is a very comprehensive map because every building from the cadastre has a unique number here. And after this number, there is a set of information for the building. The present study is based on the methodology for analysis, evaluation, and mapping of seismic risk for Republic of Bulgaria, developed from our institute for the Ministry of Regional Development and Public Works, approved by the Minister and having the force of a normative document. The first step is to identify the regions with equal macroseismic intensity, referring to the seismic intensity map. Then each building is assigned to a relevant vulnerability class, following the procedure based on EMS. The buildings are grouped according to their vulnerability classes from A to F. To each group of buildings, the number of those that reach certain damage grade is calculated directly using the values of damage probability matrix for the vulnerability class and depending on the seismic intensity for the location of the building. The buildings with equal damage grades are selected among all the buildings in the region with equal intensity and belonging to the same vulnerability class. In this way, the number of the damaged building is determined. Subsequently, the area of the damaged buildings, according to the damage grades, is also calculated from the GIS database for the region. That area is used for the assessed monetary loss and the human casualties. The next step is identification and classification of the building stock. Rus is the 5th largest city in Bulgaria with a population of near 140,000. Rus is situated in the northeastern part of the country on the right bank of the Danube in the mouth of Rusinski Lom River. It is the most significant Bulgarian river port. The city's administrative, transport and tourism center of Bulgaria. Rus is known for the 19th and 20th century Neo-Baroque and Neo-Rococo architecture. You can see several pictures for these beautiful old houses. The total number of buildings in the city of Rus is about 36,000. The total built-up area is around 10 million square meters. These two tables, 1 and 2, represent the distribution of buildings by pieces. And first one is, for example, the distribution by number of floors. There are 4 groups of floors, 1 to 3, 4 to 6, and above 10. You can see that most of the buildings are in the first group. And the second table is the same distribution by floors, but the criteria is total floor area. What's interesting here is that only 46% of the total floor area is in this group. One of the important parameters of the building stock is the year of design or construction. It is directly related to the current state of design seismic codes over the year. Bulgarian national seismic codes have been periodically updated and modernized. The timing of these changes is also the boundaries of the respective time periods. So we can see in these two tables the distribution of number of buildings by construction period, and again, the another criteria, total floor area. In between 66 and 77, this is the maximum, about 30% by numbers. But looking at the total floor area, the next period is more productive. And next step is distribution of buildings by typology. Based on the information about the cadastral design system, each building is classified in a separate type according to the matrix of typology of the Bulgarian buildings. The total number of typology for Russia is 10. This is the table. And you can see that half of the building stock fall in the typology M1. This is masonry structures, unreinforced masonry with reinforced concrete slabs, beams and belts not framed or framed by columns. There is also a significant number in M2 masonry structures, unreinforced masonry with wooden beams without reinforced concrete belts. Third is the concrete frame structures, RC1. And in the fourth place are the buildings, large panel buildings. Here on this diagram, you can see the distribution of buildings by typology using the criteria total floor area. You can see this is more representative than the tables. The area of RC1 typology dominates all others, but the area of large panel buildings is larger than that of the masonry. This is the large panel buildings, reinforced concrete buildings, and masonry. Next step is seismic vulnerability. Seismic vulnerability assessment is performed for each building individually based on information on its load-bearing structure, typology, construction time or design, stories, and other technical parameters. Each building is assigned a corresponding vulnerability class. The results obtained are illustrated in these two figures. You can see the number of buildings in percentage in vulnerability classes. And here is total floor area. You can see that vulnerability classes B, C, D here are approximately equal, but here is a big difference between C and D and all the other classes. A seismic history of Russia shows that the hazard of the city is mainly influenced by the intermediate depth quakes occurred in the region of Andreev, Romania. The scenario is based on the information about the S30 for the built-up part of the city. This is this picture. And the scenario earthquake is with magnitude 7.5, Andreev quake at the depth of 94 kilometers and hypocentral distance of 240 kilometers. Here you can see the distribution of the S30, and here is the intensity from 6.7 until 7.5. Next step is assessment of direct damages and destruction. The building stock of Russia is divided into three main groups, taking into account the specifics of the urban development and available information on the function and habitation of the buildings, residential buildings, industrial, commercial, administrative buildings, and finally special buildings. The first group includes residential buildings in different parts of the city. The second group includes all industrial buildings in the industrial areas, farm buildings and administrative buildings in the rest of the city. The third group is conventionally called special structures. It includes buildings with a high concentration of people and those of particular importance in the post-earthquake period. This group includes hospitals, schools, university, and kindergartens. The distribution of buildings by number and by total floor area in the different levels of damages is summarized in the next table. You can see the damage grade, no damage, light, medium, heavy, very heavy, and destruction. And this is the distribution, number of buildings, and white pieces, and this is in percentage, and again by total floor area. The built-up area of buildings without and with slight damages is around 65% and 26% respectively. Well, following are the buildings with moderate damage, around 7%. High level of damage are relatively low, 1.6 for heavy and 0.3% for the very heavy damages. The area of the destroyed buildings is minimum, 0.1%. These two figures illustrate some of the results obtained. The most significant damages are observed in the central part of the city, where the oldest buildings are located and the seismic intensity is highest. In fact, the intensity is 7.5. In assessing the consequences, it is very important to know the distribution of unusable and demolished buildings so that the volume of restoration work can be planned in advance. The next table summarizes the results obtained by detailing the respective group of buildings. Here you can see the unused buildings and demolished buildings by pieces and by total floor area. Next step is assessment of social losses, injured people and victims. The population of Russia is around 140,000 people, according to the data from national statistics. The results are available in two variants, depending on when the earthquake occurs, day or night. In this table, you can see the distribution of affected people, injured and victims. This is injured by day and respectively at night. The next table illustrates the distribution of injured by category. We are looking for three categories. S1, minor injured, S2 in need of hospital treatment, and finally S3 severely injured. The number of people who remain without shelter need for accommodation is in the range about 1,400 people. If the earthquake is in the summer, these people could be temporarily housed in a tents. If the earthquake is in winter, they must be housed indoors. At the average rate of 6 meters squared per person, the required indoor heating area is around 8,000 square meters respectively. On the basis of detailed data on injured people, the need of hospital beds are determined immediately after the seismic events is during the day around 110 to 120 people, and during the night around 200 people. And finally, estimation of economic losses due to direct physical damages and destruction. The economic losses are calculated on the basis of the results obtained for the damages and destructions on the three main groups of buildings. This table summarized the data. Comparison of the results for individual groups shows that the largest share of buildings is the first group, residential buildings, around 82 million. The losses in the second group of buildings, industrial and administrative, are small, approximately 40% of those in the first group. The losses in the third group, special buildings, are much smaller, which is favorable in terms of their importance immediately after the earthquake. Conclusions. The assessment of consequences of catastrophic earthquakes is based on procedure for integrating seismic hazard with seismic vulnerability of building structures. A detailed quantitative assessment of the consequences in the form of losses is made as follows. Assessment of direct damages and destruction of the building stock. The results clearly show that residential buildings are the most vulnerable, and during an earthquake will suffer more damages than the other two groups of buildings. This fact is important and should be taken into account when planning the necessary resources, building materials and labor, to recover the damaged building stock. Assessment of social losses, injured people and victims. The assessment of casualties and injured is based on parameters that take into account the specific conditions in the study area, such as type of construction system, building density, time of event, etc. In assessing social losses, the results are obtained in two variants, depending on when an earthquake occurs, day or night. The number of people who remain without shelter, need for accommodation, is determined. On the basis of the detailed data on injured people, the need for hospital beds is determined immediately after the earthquake. In general, social losses are greater at night. The main reason for this is that then people are at home, and residential buildings are the most vulnerable and with the greatest damages and destruction. Estimation of economic losses due to the direct physical damages and destruction of the stock of Russia. These amounts can be used to develop disaster response plans and plan the need of financial resources to rebuild the buildings. And finally, the relevance of management decision-making results and their benefits to society. Opportunity to develop a well-grounded prevention program, opportunity to priority planning of rescue teams, equipment, resources by the Russian municipal administration, and finally, ability to plan the need for hospital beds and shelter. Thank you very much for your attention.
The 5 speakers to pose the questions. I know that we have no question in the chat box, but maybe from the audience, if somebody is willing to pose any questions, please go ahead. If not, we will have a question.
Hey, don't be shy.
I know that sometimes it's very tough to ask the question to the really specialist, but always remember, there is no silly question. Could be vice versa, the answer could be, but...
If there are no questions, can I invite the Dr. Bocheva here again, just for microphone? Because we have one small question. Doctor, I have a question connected to your presentation, and my question would be, what level of the hail intensity we can say that is dangerous for humans? And also another part, it's what is the tendency of the hailstorms formations in the future for territory of Bulgaria?
The level of hail intensity in Bulgaria, I said that we didn't measure the size of hailstones. We have only the some sign from media about this, and we have no full records about not only in centimeters, but like a grain or a beam or ball, a small one or something. But it depends of the duration of hailstorm, because sometimes small hail size even below 2 centimeters can be more dangerous if the duration is more than 10 minutes, because it make something like a snow cover, but it's a hail cover. It's more dangerous for agriculture and the other aspects. But actually, in Europe, many countries, they signed only hailstones over 2 centimeters. So their records are only about this, because they're dangerous, of course, for people also, and for buildings, agriculture, vehicles, and the other stones. What concerns the model data for future climate, we expect more frequent convective storms in Europe. So the region of Balkans and South Europe will be affected with more severe convective storms. So we expect, yes, we expect more damages from these events, and it became more frequent in recent years.
Okay, so we can clearly say about, based on your assessment, that especially for those our colleagues who bought the cars, the new cars,
yes,
it's better to have a good shelter for them. Yes.
Yes.
Yeah.
And a roof.
A roof, kind of underground parking lot will be the best one. Otherwise, you will have a perforated, roof, and only your mechanic will be happy. Okay, thank you so much.
Thank you very much. Thank you.
If I may ask to come here, Miss Nadezhda Miteva. Don't worry, we will not kill you, especially with hail. First of all, thank you very much for your briefing about this Resilog project. I frankly said I heard it first time, and I not realized that such project is run out here in I guess in Europe as well. Yes, this is a European. So I assumed that by this project you can assess the current resilience status in such community, and then you can also gather the basic needs, what the local society need for the resilience. So you can measure a kind of delta, what they have now and what's supposed to have, what they want to have. And you was talking about a quite small community, Tetovo. Can you tell us what was the main source of your information? It was from the citizens, and how you gathered this? This was a survey, or this was face-to-face talking, or how you gathered the information?
That's an interesting question because each of the dimensions that I briefed you on requires different sources of data
Exactly.
ex ante. And when you don't find the data that is by default needed, you need to go back to the citizens. So just a couple of examples. In the social dimension, there were roughly 30 proxies for which we conducted a survey on site, and we collected information on that in the community. Then we are also very lucky to be working with the local authority of the town hall of Tetovo, so they have access to the state system, information system, so the population registry, national statistical services, data that they also gather for their strategic plans on an annual basis is available to us. And we also work with the Bulgarian Red Cross, who are a partner in our project, and they also have very valuable information. So from wherever, we are also now going to contact the National Electric Company to gather information on the infrastructure dimension for those indicators that have been deemed relevant for the community.
Are there any other communities maybe who request such analysis, or this was just the sample in Tetovo?
We have focused the presentation on Tetovo just because it's our trial site. There are 3 more trials that are ongoing right now. One is in Catania, one is in Gorizia, which is the cross-border region between Italy and Slovenia, and the 4th one is in West Achaia in Greece. There are different stages of the trial process, but they're all ongoing. And we have actually been requested from a small town near Tetovo for them to come and see how it goes so that maybe they also implement this framework.
I hope that all of them will be fair sharing, the information with you, because this is the baseline to have a fair information and accurate, yeah?
Absolutely, and I hope that we can empower them to assess themselves against their needs.
Thank you very much.
Thanks a lot. I have one question.
Yes.
Absolutely, sir.
Did you have the opportunity to assess your results? To see if your results are, let's say,
implemented,
valid, or to verify them? When you compare the actual results with your
we saw at the end this SWOT matrix, which can be provided to the local communities. What they have opportunities, yes, what they have threats. Have you observed any opportunities they use it or implement it? Not yet.
Not yet. As I mentioned during the presentation, we are in the first stages of the trial. So at the end, we will co-create, or the community will lead the creation of their local strategy. So the local resilience team will come up with a draft strategy for resilience improvement that will then be validated with results against the larger community. And hopefully they will be acting on some of the measures that they identify as necessary.
But at least they have a good tools to adopt their strategic plans, yes? I hope so.
Adoption, we are not so sure. It will depend on the community that is taking up the strategy, because it varies in administrative powers to adopt some strategic measures and not to adopt others. And I think in Tetovo we'll be focusing more on soft measures and increased lobbying for improvement.
Yeah. Thank you so much.
Thank you very much.
Thanks a lot.
Okay, with this statement, I would like to introduce a short coffee break after 15:50, which means 10 minutes to 4. Thank you very much. Okay, now I would like to give the floor for Božidara Kyriakova. She is the intern in our center, and she will also present her research here during this conference. Božidara, please, the floor is yours.
Thank you, sir. Good afternoon to all the participants here and present and online. It is a pleasure for me to welcome you to my presentation, which will focus on the significance of risk communication for achieving societal resilience through civil preparedness. I believe that this is another topic of great importance due to the fact that additional emphasis needs to be placed on risk communication within the crisis management and disaster response domain. And my main objective will be in the following 15 minutes to demonstrate exactly why. So first, I will begin with introducing different types of risk perception, why these are important within the risk communication process as a whole, and what different mental strategies people tend to apply when they assess new information and when they reach decisions, especially in times of unpredictable events with high levels of stress and limited amount of time. Then I will focus on the phenomenon disinformation, why it is important, and why trust is also important in terms of risk communication, following by specific strategies and how societal resilience and civil preparedness is linked to communicating risk. So risk communication as a normal communication process could be analyzed with as a process including two sides. So on the one hand, we have institutions and organizations which are responsible and entrusted for providing crisis management activities, enhancing societal resilience, disaster response, which are in this case the sending end, so they are generating risk communication messages. And on the other hand, we have the public, which could be observed as the target audience, the recipients of these messages. And in this case, I would like to place additional emphasis on how different societal groups tend to perceive risk and what are the current levels of trust in those important institutions and organizations. Risk can be perceived from different perspectives. Some experts focus on the social cultural background of individuals, so how this background exerts influence over the perception, reaction to risk on behalf of women, men, boys, and girls. Other experts focus primarily on the fact that individuals tend to find relation between the levels of risk and the levels of social benefit which could be derived from this risk. So there is a higher level of acceptance towards a risk if it could lead to bigger economical, technological, social benefits in general. And last but not least, there are studies which find differences between the ways experts and non-experts perceive risk. For example, experts relate riskiness to expected annual mortality, as studies suggest, whereas non-experts relate risk to lack of predictability, lack of stability, fatal consequences, and negative outcomes in general. However, all these types of perceiving risks should be taken into account because at the end, all these societal groups form part of the public, which is the main recipient of risk communication. And in order for these messages communicating risk to be well perceived, the expectations and needs of these societal groups needs to be taken into account and properly addressed. However, people in general tend to apply several mental strategies in order to assess information and to reach decisions. The first one is called heuristics. This is time-efficient mental strategy, which lessens the stress when the decisional task is quite complex and there is a limited amount of time. However, individuals should not rely only on this strategy because it could lead, and studies prove that, to persistent biases, risk misjudgments, or even risk denial. Other theories which I have included here in my presentation are first the cognitive experiential self-theory of Seymour Epstein, who introduces the idea that there are two mental systems which operate side by side on an individual basis. The first one is cognitive, which is more analytical and on a conscious level, whereas the experiential, as its name says and suggests, is based on the personal experience of the individual, so it's more intuitive. The double or dual process theory introduced by Kahneman and Tversky also focus on two cognitive systems which operate side by side. And here we also have one which is more fast and associative, and another which is rather slow and deductive. These mental strategies should also be taken into account within the risk communication process because they exert influence over the ways people analyze the information which they have received and how they will further on react to this information. Another concept which should be introduced here with regard to the information environment is the phenomenon disinformation. And here I have included one explanation of this phenomenon. So this is the deliberate creation and dissemination of false and or manipulated information with the intent to deceive and or mislead. So this is a very important topic, which has been already subject of analysis on behalf of different organizations and institutions and experts in the field. Concrete actions have already been taken in order to counter disinformation. For example, UNESCO has released several publications on media and information literacy. So this focuses on how individuals can spot and counter false or misleading information. It is also related to critical thinking. On the other hand, NATO is actively engaged in a wide range of media engagements, places emphasis on the active coordination with partners and institutions, tends to analyze the information environment itself, and provides tips to citizens on how to spot and counter disinformation. The World Health Organization has established a framework related to building a response workforce to manage infodemics. So they focus on infodemics as including related to mis and disinformation in times of acute public health events. And the European Statistical System Task Force on Strategic Communication has published rules of engagement for handling disinformation this year, 2022. So as you can see, a lot has already been done in order to counter disinformation. Yet a lot is still to be done because recent surveys from 2017 and 2020 prove that a lot of people believe that the system is failing them. For example, 53% of the participants in these surveys believe that the system is failing them. The majority of people distrust their institutions in their respective countries. many people believe that the system is not working for them. And as you can see here, 4 institutions, NGOs, government, media, and business are taken into account. None of them is seen as both competent and ethical. In this case, competency is understood as delivering on promises, whereas the ethical behavior is perceived as doing what is right and beneficial for the society. As you can see here, governments are in the least favorable position, which is quite an alarming fact, because they are quite active with regard to addressing risks, tackling crises, and providing solutions to disasters. What about the risk communication strategies? They could be analyzed in relation to the main phases of crisis, pre-crisis, crisis, and post-crisis. Some experts place emphasis on the initial preparation, so during the pre-crisis phase, whereas others focus mainly on the recovery, the assessment of damage on the organizational reputation, so focus on the post-crisis phase. Nevertheless, risk communication is advisable to be active throughout the entire process. And another way of analyzing is by introducing the components of risk, outrage, and hazard. So hazard is related to the technical or scientific measures of risk, and outrages includes the emotions which this risk evokes. So as you can see here, there are at least 3 different risk communication strategies, each one having its own main objectives and goals. In general, risk communication should provide quick response to the necessities and needs of the target audience, in this case, the public. It should provide accurate and credible information. It should promote action when necessary. And it should express empathy and respect to the main recipients. So how is societal resilience and civil preparedness related to this? As you can see here, for example, the CIMIC Center of Excellence includes population as one of the main stakeholders related to achieving resilience through enhanced civil preparedness. And as such, it should be properly informed regarding such key events related to the risk situation. Other organizations also place emphasis on the civic engagement and the community engagement. For example, NATO Civil Emergency Planning Committee provides civilian expertise and capabilities with regard to humanitarian response, disaster response, protection of critical infrastructure. The EU Civil Protection Mechanism aims to enhance the cooperation between EU member and participating states and to improve the response, prevention, and preparedness measures with regard to disasters. The World Health Organization observes community engagement as a key area of focus with regard to enhancing preparedness, urban preparedness for countering and effectively recovering from events such as the COVID-19 pandemic. And one of the projects funded related to the European Commission Civil Protection and Humanitarian Aid Operations Department is mainly focused on informing citizens of the main pillars of disaster management, informing citizens of their own key role in this process, and the adaptation and applying of different awareness raising tools. So this is what I've chosen to present today. The full list of references and the article will be available upon its publication after the conference. But as main conclusions, I would like to simply add that the COVID-19 pandemic, for example, has demonstrated that, yes, there is a lot done in the area of communicating risk, but there is still a lot to be done because evidently a lot of societies have proven to be not 100% prepared to adequately face and quickly recover from this emergency situation. Thank you for your attention.
Thanks a lot, Božidara. Can we check if we have online Dr. Plamena Rajkova?
Yes. Hi. Do you see me, hear me?
Doctor, can you hear us?
Yes, I hear you.
Thanks very much. And please share your presentation and we are ready.
Okay. Hi everyone, my name is Plamena Rajkova from National Institute of Geophysics, Geodesy and Geography, Bulgarian Academy of Science. The topic of my presentation is earthquake risk scenario for the city of Veliko Tarnovo. Earthquakes advertisely affect large parts of the Earth. Global seismic risk and vulnerability to earthquakes are increasing steadily as urbanization occupies more areas that are prone to effects of strong earthquakes. Earthquake scenario and social vulnerability metric are combined to identify the vulnerability of exposed population to seismic risk and location of area with high exposure and vulnerability level. Seismic risk scenario may have different forms and outputs, but almost they present a combination of the vulnerability of one event and its negative consequences. Nowadays, there are tools that use the capability of science to protect human life and health, also the economy and the environment. These studies focus on the seismic hazard and population exposure for one large city of Bulgaria. This is the city of Veliko Tarnovo. I will speak a little bit for the city of Veliko Tarnovo. Some picture of the city is presented here. The city of Veliko Tarnovo is situated in the central part of northern Bulgaria. It also is located on the slopes of the beautiful and meanders of the Yamna River. Nowadays, the city of Veliko Tarnovo is an important administrative, economic, educational, and cultural point of northern Bulgaria. The recent tectonic of Bulgaria is determined by the geodynamic of the region, in which dominate the process of extension with a general direction north to south. In the figure here are presented instrumental and history seismicity around the city of Veliko Tarnovo. Analysis of the focal mechanism in the area shows that the normal type of movement is dominate there. I will tell a little bit seismic history of the city. The city of Veliko Tarnovo is part of Gorno-Oryahovita seismogenic zone. The seismic history of the city showed that the earthquake from 1930 with moment magnitude 6.8 caused the strongest on the city seismic effect. About 95% of the buildings in Gorno-Oryahovita and 80% of them in Veliko Tarnovo were destroyed. In the figure here, I've presented some damages after this earthquake.
to determine the solve properties and ground motion accumulation for the city of Tsunami. Presentation of the solve properties of city is defined by the parameter base 30. This is average wave velocity in the upper 30 meters of the solar profile. In the figure here are presented the variation of these parameters for the city, the area of the city of Tsunami. These parameters vary between 320 to 470 meters per second toward the urban area. Most of the territory is characterized with a velocity higher than or equal to 360 meters per second. For this city are considered selected, also tested 6 ground motion models for the shallow earthquake and 3 ground motion models for intermediate earthquakes. In this figure is presented the deterministic scenario for the city of Tsunami. In the deterministic scenario evaluation, specific value of magnitude can be associated with individual sources in order to compute via attenuation relation for magnitude and ground motion parameters the severity of ground shaking in the urban area of interest. The work on this scenario was guided by the perception that usable and realistic ground motion map had to be produced for the urban area. In the figure, deterministic scenario for the earthquake with moment magnitude 6.8 was defined on the basis of the seismogenic potential of the co-city faults. In the figure is presented the variation of peak ground acceleration for the city of Tsunami. The highest PGA value are in the northeastern part of the city. Next steps is to determine the probabilistic seismic scenario for the city. First, the probabilistic seismic hazard is the probability that various level of ground motion will be exceeded during a specified time period of the site. Also, the ground motion level may be expressed in terms of big ground acceleration, velocity, displacement, and of big response spectral amplitude for a range of frequencies. To determine the probabilistic seismic scenario, it's necessary to make some steps. First, we terminate the seismic source model. The seismic source model demands translating tectonic information into spatial approximation of earthquake location and recurrence. This is a key component of seismic hazard assessment. In the figure here is presented seismic source model for the city of Tsunami. Seismicity in the 200 kilometers region surrounding the city of Tsunami associated with 15 seismic sources. Next step for the probabilistic seismic scenario is to estimate seismic source parameters. And final step is the accounting the distinct uncertainties in the seismic inputs. These uncertainties came from statistical or modeling variation. Modern methods of seismic hazard analysis incorporated uncertainties into the analysis to assess their impact on the estimate of the expected level of seismic hazard. In the next figure, next slide, are presented 2 figures. One presents the probabilistic earthquake scenario for the return period for 475 years return period and in terms in PJ, and this figure presents 1,000 years return period probabilistic seismic scenario for the 1,000 years return period for the city of Tsunami. Here, the peak ground acceleration vary between 0.21 to 0.24. Here, the peak ground acceleration vary between 0.31 to 0.37. The earthquake risk scenario for the city of Veliko Târnovo is assessed by taking into account the seismic hazard and the population exposure as an element of risk. The risk depends on hazard, also population living in a given exposed area, vulnerability, which depends on some additional factors like economic and social. This city is a relatively large city, 15 in terms of population and 70 in terms of territory for Bulgaria, with almost 6,200 residential buildings. Almost 3/4 of the buildings have low-rise construction up to 3 floors, but they represent only 22% of the living space in the city. Nearly equal number of people live in buildings with floors between 4 to 6 and 7 to 10. The highest density of population is observed in the central and southern part of the city. The population exposure, one equation is presented here. After using GIS, we overlap the seismic hazard and population living in the potentially affected area of the city of Veliko Târnovo. The input data which are important in geoinformation system and used for the analysis are the seismic hazard, the deterministic scenario, and probabilistic scenario with return period for 175 years return period, and distribution of population according to the total numbers of citizens. This equation here is applied to obtain the population exposure at base level earthquake risk scenario for a single element. We also use the 5 classes of standard risk matrix from minor to major, and here we present 2 risk scenarios. First is associated with the deterministic seismic earthquake scenario for the earthquake with moment magnitude 6.8. In this scenario, we have 3 categories of population exposure index: moderate, high, and major. The most endangered sites uneven space over the territory of the city, predominating in its central and southern part. The second scenario is associated with the probabilistic seismic scenario for the return period 475 years. Here we have 4 levels for the population exposure index from the major and the high and major are also in the central and southern part, and low and moderate risk classes are observed in the western and east-northeastern part of the city. In conclusion, it should be noted that our result presents a base level earthquake risk scenario, which might be upgraded to fully operational too if the infrastructure of the city and building vulnerability analysis is added to it. We also want to thank the support of these 2 projects, and thank you for your attention.
Thank you very much, Doctor, for your presentation. And the last briefer for today is Mr. Georgios Paschalidis, and he will present the topic related to military. Sir, can you hear us?
Loud and clear, sir. Can you hear me? Do you hear me, sir?
Yes, we can hear you.
Perfect. Thank you very much. I will share my presentation and I will start in 1 second. Good afternoon from my side. I'm Pascalidis Georgios. I am a military engineer officer. I will try to enrich Dr. Todorov approach, and I will shortly brief you for depleted uranium for military purposes. The agenda has 4 parts. I will initially present depleted uranium characteristics, the use of depleted uranium, NATO doctrine, and a small summary. Depleted uranium is the uranium with isotope fissile content uranium-235, lower than the natural uranium, which has a content of 0.72% in uranium-235. The biggest quantity of depleted uranium is a result of the procedure of enriched uranium, as you can see in the picture, in which we will be used at nuclear reactors as fuel and at the construction of nuclear weapons. Depleted uranium is used for the protection of the radiation during medical treatment with radiation, to the construction of metal cubes, for the transportation of radioactive material, at industrial equipment for X-rays, but mainly for military purposes. The military industry uses depleted uranium for the armament of the tanks and at the piercing ammunition, and is stored in special barrels under pressure like gas. In the matrix is compared the concentration and the emitted radio energy between depleted uranium and natural uranium in order to realize the possible level of threat. As you can see, the first column shows the concentration, weight per weight, and the second the emitted radio energy. After the comparison, the percentage of depleted uranium remained compatible. Depleted uranium ammunition is not a new ammunition. 300,000 missiles have been used at Gulf 1991. 15 tons ammunition with depleted uranium used from NATO forces at Kosovo 1999, used in Afghanistan, in Mali, and in Syria. In the 2 graphical maps, you can see areas that depleted uranium ammunition have used. The first one is in Iraq, and the second one in Kosovo. In Kosovo, also have been done researches for the concentrations and the result of the local population. Similar situation exists also in Greece. The use of depleted uranium ammunition in the sea training area of Managro from Hellenic Navy during exercises for the readiness of naval personnel worried the local peoples for the environmental risk of this ammunition in the area. Moreover, in general 2003, Hellenic Armed Forces used 20,000 depleted uranium missiles in maritime and land maritime exercises in the Aegean Sea. The question, the question is if this ammunition used in Ukraine last month. The information that released from the Ukrainian forces are limited, but it's confirmed that the Russian forces using the operation 2 types of tanks, T-72A and T-80 Bravo V, that have the capability to use ammunition. My personal assessment is that in a war, that if you have the capability in order to have the military advantage, probably you will use it. But I would like to highlight again that this is my personal assessment. Depleted uranium is used in army forces for 2 cases: as armor of the tanks and at the piercing ammunition. Starting with armor of the tank, the military industry uses depleted uranium because it has 2.5 times bigger density and it's harder than the steel, in order to face the threat of piercing missiles. The worries of the scientists focus on the danger of the use of this ammunition when it strikes an armored target or in an embankment in a training area, and the military personnel breathe this powder. The spread, the concentration, and the chemical analysis of the small particles, like aerosols, can enter at the lungs and is assessed that can reach at 96%. The situation is more effective, especially for the personnel who are close to the target during the explosion, or the personnel that examines the result of the explosion or the target, like an old armored tanks. A crucial factor for the spread of this flying powder is the meteorological conditions. The wind or the rain are the most important of them because they can increase the velocity and range of the spread. Also, the use of piercing ammunition increase the concentrations. I would like to highlight this threat also in the training areas. Usually training areas at the mountain slope, for example, exist an ordinary use of depleted uranium missiles and have been identified big concentrations of depleted uranium. As a result, when we have a rainfall, a quantity of them will transfer to underwater and may affect the quality of the water. Due to the environmental conditions, the metallic parts of the ammunition of depleted uranium are vulnerable to oxidation. The oxides spread at the ground, and these heavy metals emit ionizing alpha, beta, and gamma radiation. Additionally, this spread at the neighborhood agriculture areas during dark conflicts or training, or some unexploded ordnances expose the farmers in danger with the radiation of the ammunition, and moreover pollute the ground and the cultivation because of oxidation. Under these environmental conditions, the chemicals are soluble and can diffuse at the surface and underground waters, and through this route to insert at the food chain and at the end of the consumed from the humans. As a conclusion, is a fight between the armor and the piercing ammunition which will be the most effective. NATO identifies that depleted uranium has special and toxic chemical properties and care must be taken to incorporate it safely. NATO has developed and doctored different documentations concerning depleted uranium. Starting with the storage facilities for depleted uranium ammunition will usually be located in military control sites at distances from the nearest point of public access beyond which the predictable explosive inhalation and surface contamination effects will be acceptable. As you can see, the first doctrine, Allied Ammunition Storage and Transportation Publication 1. A second area of interest is the radiation protection of military vehicles. Guidelines to improve the radiation protection and an assess decision process has been developed in order to certify at least the minimum standards for the military personnel. The requirements for potable water during field operation and in emergency situation is an area that maybe will be affected from the use of depleted uranium. So NATO developed a risk assessment process concerning long-term standards for the quality water. For uranium, in general, they collect samples and they make tests once per year, following the limits that the World Health Organization has defined as maximum concentration. NATO has also accepted the 0.03 milligrams per liter. The last area that NATO developed a doctrine is clearance decontamination. This documentation provides guidance on cleanliness levels that may be acceptable in order the threat to be eliminated. In more detail, analyzes the risk levels, the equipment that must be used, and the minimum requirements that process demands. As a summary, I would like to refer in two things. The first is that the use of depleted uranium exists the last 35 years during armed conflicts. An armed conflict is a situation that is unstable, and under these circumstances, the use exists in order the two parties to take a military advantage. This threat has been recognized, and we must do all the proper actions in order to avoid environmental risk. The area that remains unknown and seems that nobody deals with environmental risk are the concentration of depleted uranium in the training areas. I believe that is an area that we ignore. An ordinary threat for the military personnel without any research or any data collected. The last point is that despite the fact that NATO has already identified and developed depleted uranium has special and toxic chemical properties, the areas which have been covered are very limited. These two bullets keep the threat active, and we must always keep in balance the use of depleted uranium with the causing environmental risks. This concludes my briefing. I will present you a small video for a technology of piercing ammunition, mainly for the civilian participants. It's only 1 minute. Please, sir, be patient for 1 minute.
Armor piercing.
Thank you, sir. I am at your disposal for anything else we can need. Thank you very much.
If not, we have one.
They are not on the floor? Okay, Georgios, there's a question to you, if I may. What I recently read that many of the projectiles, I mean, this piercing ammunition, is really outdated, is older than 30 years, and sometimes is more dangerous for users than for potential targets. According to you, do you think that users, or let's say some countries, because not all countries possess such ammunition, they will try to withdraw from this ammunition or they will keep it? What is your opinion?
Personally, sir, I believe that the ammunition the countries have already paid for them, so probably or they will sell it in another country to use it somewhere, or they will use it for training.
Okay, thank you. And next one, very short one. Do you think that some terrorist groups can be interested to possess, this depleted uranium? Of course, let's say I'm not expert, but from my perspective, they are not able to produce the nuclear bomb from that, but the dirty bomb for sure. Do you think that they are interested or they can possess something?
I believe, sir, it's a totally correct approach. I believe that especially for buildings or some VIP cars that they want to hit, it's a very good ammunition.
Yeah, thank you very much. Thank you very much for your input. Okay, I think that on this moment we can make a short wrap up of the day, and just let me rephrase that our main motto for today's panel is natural hazards, risk reduction, and building resilience. And through entire day today, we were provided with many informations, and we can identify a lot of natural hazards, which are in the not only territory of Bulgaria, but in other places as well. So we were briefed about landslides, floods, mud flows, which can be caused by the heavy rains, especially in the mountain areas. Also, hail rains as a hazard for example, for traffic, I mean railroad, air traffic, houses, agriculture area, and of course for human beings, for lives. We are briefed about heavy storms and high waves as a hazard for Black Sea, which could also possess the danger for ship traffic and for coastline itself. We are informed about natural radiation as a hazard for the population. There were some thoughts as well about strong earthquakes, which can induce tsunami. Also, the flooding hazards on the seaside coastline was pointed as well. We were presented also by typical challenges for the risk communication, which mean about the liability, informed consent, and so-called right to know, as well as the sharing of power. Then we got some information about seismic risks, especially for the seismogenic zones, and there was a Veliko Trnovo case study presented. And last but not least, we just got the briefing about the use of depleted uranium and the hazard, which is typically built by the human. However, from the other side, we also were informed that we have a lot of tools in the hands by which we can reduce the risk and we can build up our resilience. And what was mentioned is the real-time radar picture of the hail clouds, which can be used as a warning system for instance, for crisis management operational centers.
We were also informed about data with 3 days in the head prediction about huge waves, which can be used by the local authorities from the Black Sea coastline, like Burgas, like Pomoria, which was pointed as a more vulnerable for that. And this could give the local authorities the tool to at least inform the citizens about the risk coming and to alarm the rescue services to be ready. We can use, we are informed about the usage of building resistance, or I would say vulnerability analysis, which are based on the ambient noise records. Even with pointing which part of the building is more resist, which part is less resist. We are in possession of a very big data of earthquakes and tsunami hazards. And it was pointed here about Marmara Sea area. But when you can compare that Marmara Sea, then Dardanelles Strait and the Istanbul Pass is the only way which connecting Black Sea with the Mediterranean Sea. So if something there will completely collapse, the Black Sea could be the internal sea. Then we heard about the RESILOC project with framework and tools. And it was pointed in the several dimensions, like environment and governance, but also a social and economics, which can be used to assess resilience status on the local community, and then the resilient needs for a respective community, as was pointed for the Tetovo municipality here. And it was presented also afterwards, the local community can be provided with a kind of SWOT matrix, which is pointing them correctly about strengths, weaknesses, opportunities, and threats. We were also informed about importance of safety of the local community, especially in the area of ability to adopt, so-called adaptability. Then we talk about seismic risk and vulnerability assessment, especially when compared with the possessed building stocks, can be provided to the local authorities with a specific and detailed kind of mapping of their area of responsibility. Of course, it is when they can, where they can expect heavy damages, which of course, from the other hand, giving them information where to allocate resources and where to put the main effort. And this was presented on the Rusem municipality. And finally, the risk communication as an essential function for effective and accurate exchange of information about risks and hazards. So let me summarize with just 3 sentences. As far as I catched, at least during today, we have plenty of tools to deal with building up our resilience. We have plenty of tools. And we have many lessons identified. But unfortunately, we have less lessons learned. And this is what I can sum up and underline today's panel. Over to you.
Thank you, Darius.
Just give me 5 seconds, and I guarantee you will be
out
shocked.
of time, but
okay.
That's
So
okay.
I will just stop talking
just 15
right now.
minutes. And
as you can see, my lips are not moving.
Thank you very much for participation in this conference day, also for sharing your knowledge and your research. Just want to remind you one more time about the icebreaker, that it will happen tomorrow at 5:30, and tomorrow we will touch few panels of the conference, but we will start with the climate change challenges and security. implications. So I think it's now a good timing to close the session, and I wish you all the best and a good evening, and we will start again tomorrow at 9 o'clock Sofia time. Thank you very much.
Хубав вечер и до скоро.